Recording.
Okay, for online folks, I mean, you should be able to run the presentation view and the video feed side by side. Okay, there is a setting in the Zoom, so that you can see both at the same time. Okay, just try out that setting.
You already had shared the screen?
Not yet. Yeah. You can save the whole thing, yeah.
Good morning, everybody. We're about to start software quality assurance. Harshal and I teach. My name is Dilip Patel. We teach these classes together. We've been doing now what for 8+ years?
Since 2015, yep.
Yeah.
We've been teaching this camp, conducting the camp here in Columbus. Yep.
So here are the contact information for us. A little bit about that. I think all of you probably already have met Harshal before.
I think we all spoke on the phone. I
All
never
spoke
met
on the phone, you
anybody in
never met?
person. Except Joyce. I mean, she was here.
Yeah.
So, yeah.
So this is a little bit about Harshal, like he's been, I think we need to update this, it's more than 24
Yeah,
years now.
it's 25, 26.
Yeah.
So.
So he has an MBA from University of Dayton and has done tons of certifications. Primarily, he works more as a principal consultant with Intelligent Software, working with a lot of clientele to build software solutions end to end, including architectures, deployment, and testing and development of all of the software. That's where his main focus is.
And my background, I mean, bachelor's is chemical engineering. So that will make you guys feel better. I'm a chemical engineer, but in IT. So yeah. But yep.
Yeah, I'm a little bit more close.
Yeah.
I'm a little bit more closer to the computers. My background is in electronics engineering, and I did my master's in computer science. And then I've been working 25+, almost same time as Harshal has been. So right now I'm working at JP Chase. I kind of like it's focused on transformation aspects of the bank, where I'm kind of like it's getting them adopting into the new ways to build the software, which is more continuous development and delivery model. So typically most of the firms do its software development and delivery once every 3 months or so. We're trying to get into the mode where it'll be pretty much every day, every other day software is delivered into the real life production mode.
So you did a lot of Agile, help with a lot of Agile transformation and JP Morgan, and cloud.
Yeah. And prior to that, I also taught 10 years at Franklin University as adjunct faculty. So,
All right.
let's do a quick round of introduction. So what I would like all of you to tell me a little bit about why you're here and any exposure that you had with the computers.
It's okay if you don't have anything, okay? That's perfectly fine. But if you have something, just we like to know. All right.
Yeah. Why don't we start with you, John?
Okay. Hello, everyone. My name is Juwan. It's right here. I'm here to learn, of course, QA, software testing, and I have zero knowledge about software testing.
Yeah.
So about computer, I'm kind of nervous.
No, that's fine.
You don't have to be nervous. There's not many people here.
Everybody likes it.
So I took some course in CompTIA, and I have a CompTIA certificate in networking and like basic computer.
Certainly.
That's it.
Great.
That's
great.
all.
Hey, anything you have it, I think that's gonna be a plus. So, yeah.
Hello everyone, this is Bhagyashri. As a profession, I'm teacher, so I have zero knowledge like Joan. And then I just want to shift my career to the IT, so that's why I'm here. So, yeah.
What do you teach?
I'm just teaching for like 6th or 7th grade student.
Okay,
Yeah.
What subjects?
In India, they don't have like any specialty,
Okay.
just for all subject. If I choose history, that's also fine, math also fine, it's like
Ah.
that, yeah.
great, great.
Hey, morning, everyone. My name is Farad. I'm an MLT medical lab technician at COPC lab.
Okay.
So,
Great,
the reason, like, I have 2 boys, busy wife working as well. She's in MA. So trying to keep up with the busy life of the boys like her, and it's not really easy, like, to
sure.
have this life and work
Gotcha.
life. And so I believe, like, the future is the IT and work from home and remote. It's like one of the best.
Right.
Anything.
There are a lot of jobs, especially after pandemic. I mean,
Yeah.
Yeah.
a lot of opportunities. You can be working for California company and you will be fine in Columbus.
Like I said, probably that's like the right choice for right now, and we're gonna give it a shot.
Yeah,
I
yeah,
don't think it's about out for granted, but if you don't try, you will never know.
that's right,
Right.
that's
Give
right.
it a shot, it works, if not, I'm like,
All right, it will work, it will.
Hey, the knowledge always helps.
like, you never know.
Yep,
Yeah.
understand. Which company you work for?
COPCP,
COPCP, okay, so Central Ohio Primary
Primary
Care,
Care, yeah.
okay, my kids go there. Central Ohio. Big company, yeah.
Go ahead, Joyce.
Good morning, everybody. This is Joyce. I've been here before. Years ago, I had a background in social work, but something happened, so I'm changing. I hear that there's going to be a big project in India coming here. So,
Right, that's
Yeah.
correct.
So I don't want to miss that opportunity, so I'm just trying to get the knowledge. So once it's done, I'll be ready to jump on it. Yeah.
That's
I
right.
also work for Chase, long time ago, Mary and I work for Chase,
I see.
Chase.
That's great. Here in the Polaris building or,
No, we are not, we are
under West
Tech
Center.
Center.
Tech Center.
Tech
Drive,
Center.
Ghana.
Ghana, okay, so Dilip probably
More
knows
so.
that,
Yeah.
then I will, okay, I see. Great,
Yeah, so that's how we got to be friends.
nice.
Tell me a little bit about you, Mary.
I am married, because, work for JP Morgan Chase.
Okay.
The home, disability, and a bad accident 5 years ago.
I see.
In home. I have a background in healthcare management and business administration, so that's
Okay.
where my degrees are. I currently want to switch to IT and take advantage of all these tech companies, financial companies that are flooding to Lambdas. If possible, I would like to do a remote job.
Okay, great. Have you? Yes, Anurag.
I studied BSc Electronics.
Okay.
It's been 10 years ago. I switched off my studies. I completed BSc Electronics. I have 2 kids. But
Great.
now I want to learn, I want to settle in software.
That makes sense. All right, great. All right, yes, so Jenny,
Hi, I'm Saujanya. I have my computer science degree from India.
okay,
Worked as support engineer in India for a couple of years and got married and never worked.
I see. So how long ago was that?
Start over again.
So how long ago was your degree?
18 years.
80.
Oh.
That's a long time, yes.
You probably worked on big giant computers, now it's very tiny. Yeah.
So yes, starting over is troublesome. So
Great. All right, online folks,
Sneha, you want to start with it?
Sneha, you want?
Yeah, sure. Hi, my name is Sneha and I have my MBA from India, and then we moved on to US in 2014. So I had a lot of gap. Then I started after COVID. I'm working as a banker in a bank. for the last couple of years. I have a little bit of experience. I have taken a couple of trainings as a business analyst and a bit of exposure to testing. So, but since we have a lot of opportunities in IT and it's more kind of flexible, so I'm looking for better opportunities in IT, and that's why testing.
Right, great.
Thomas?
Hi, my name is Thomas Amuzu. I work with PwC. It's a consulting firm, and what we basically do is just we handle more of financial crime investigations, and so it's kind of related to banking, anti-money laundering, banking, and investigating accounts, things like that. I've been doing that for the past 10 years. I don't have any knowledge or experience in IT. I'm looking to kind of pursue a career in IT, and I think based on my initial discussion with Harsha, it looks like the SKU will be a good path to start from, and then pick it up from there. So that's why I'm here. Thanks.
All right, great.
All right. Just question. All of you use smartphone? And you have a lot more experience with computers than what you think about it. All right. So let's talk through it. When we built this course, there were a few things that in our mind was like it's as I mentioned, I kind of taught at Franklin for 10 years, and I always lean towards getting it a lot more real-time experience while teaching it rather than just doing a theoretical. So what you're going to see is probably first 1 or 1.5 lecture is the only time where you're going to see a lot of more theory going. Then there will be a lot more interaction and project reports from that point of view. And the reason is we want to set up the base framework for all of you to get the basic knowledge of what is computer, what is computer software, and so on. But then we're going to dive into learning through working on the project itself. Okay. So what we're going to talk about it is as we go through the course, it's essentially, we're not going to talk about how the software is built, but how a quality assurance comes into the play when the software is getting built. Okay, we're going to talk about various software artifacts and the testing artifacts that you're going to build it along the way on your day-to-day job at the work. And then we're going to get you all of those things to real-life projects. Along the way, we'll utilize some of the tools. Originally, when we started with it, HP testing tools, but there's a lot of more tool has came in the market in the last 4 or 5 years, and that's where we shifted it to getting into more of some of those. This is an eye chart. Here are all of the things that you're probably gonna get exposed by the time you're gonna finish it with the course. Okay, so let's dive into it. Before we dive into it, there's some logistic things.
Yeah.
Okay. What we're gonna do it is first 4 weeks, right?
First 4 weeks.
First 4 weeks, we'll meet on Sundays. Partly because Herschel and I have some activities on Saturdays.
Plus, I mean, what the feedback we had, I mean, it goes too fast.
Yeah.
We conduct the same camp over 6 weeks, but sometimes it goes too fast. So
Yeah.
now we are stretching out to 2 months.
Right.
Basically, this camp.
Yeah. So what we're
So
gonna
it
do
gives
is,
you enough time for the project work and other things to get up to speed.
so first 4 weeks, it'll be Sundays, 9 to 1. And then we're gonna switch into Saturday, Sunday, 9 to 1. So that gives you more time to collaborate. And then every Thursday, we also meet online at 6:30.
6:30 to 8:30.
8:30.
That's a fixed timing, 6:30 to 8:30.
Yes.
Yes, yeah,
Yes,
everything. I think everybody is in Columbus. I think all the students are pretty much in Columbus area. So
It's only on Thursday.
Thursday's
Thursday,
online.
we don't teach anything new.
Okay.
It's
Okay.
more
It's
interaction.
more the project work, your homework reviews. That's what we do. We record it as well. So just in case if you miss it, we can get you the recording.
Oh, okay.
Okay, so for that one, yeah. I mean, we're gonna record all the sessions regardless.
So you can play it also, like it's a lot of times you say, hey, I don't know what was discussed in the class, let me just replay it and get that, right? So you can do that.
Now, the important part is, session number 3 and 4 are very important. So, 3rd week and 4th week. I would definitely want you guys to attend that because that's the core. Okay, so first two sessions are a little bit theoretical, but then we're gonna dive into the IT project. And then those sessions will help you basically understand the real thing, real what quality assurance is and how you apply for the projects and so forth. Okay, so just
Typically,
make sure you plan accordingly.
so typically when we do it like the 4-hour sessions, we go for about like an hour and a half, take like 5-10 minute break. Right, there's logistics, there's a restroom here. If you want to stretch up the leg, we can do that. There's a microwave if you like it's want to warm up something with that. I would recommend like just bring your own water bottle.
Yeah.
Because of the COVID restriction, we're trying to like.
I think we have some water
Water
here,
bottles.
bottles here, but we recommend you bring your own water or something like that, or coffee or whatever.
Coffee or whatever you want.
Okay.
Okay. So let's get started.
Yeah, well, I'll let you continue the list.
Yeah. So let's talk about first, what is a software?
Dilip, you wanna go through the booklet as well, or?
I'll go as we go through.
Okay.
Okay, so all of the slides that you're gonna see here, it's in your folder, right? It's your folder, you can make whatever the notes you want to put it on that.
For the online folks, Dilip, I'll be sending them something, I'll be sharing with everybody.
PDF, yeah.
Online, same material online.
Yeah. So Harshal will be sending it in a moment, Sneha and Thomas, for you guys, a link to the documents so you can see it. So what you're seeing here is a definition of Wikipedia. Like it's if you go on Google and search what is a software, that's what it comes in, right? In a nutshell, software is nothing but a set of instructions that your computer can understand and execute it. It's nothing else more than that, right? So if you look into any recipe, if you're like it's making a food or any step-by-step instruction for any of the do-it-yourself projects, right? All it comes in is all instructions, right? You're just following those instructions and you're executing it. And the end of those instructions, either whatever you're doing, a recipe or whatever you're making it, you get that, right? That's essentially the computer software. Okay. Now, why it's getting important, right? All of you talked about like it's, hey, you want to shift the carrier into it. But if you look at around yourself, right? Whether it's a phone, a computer, nowadays, even if you like it's look into the TV or any of the devices, which is more or less kind of connected and has some sort of electronics, has a software in it. Okay. And all it allows us to become a more productive, right? And the way it does it by taking certain inputs, it does processing and provides an output. Let's take an example of even as simple as PowerPoint, right? Take an input that we are creating a slide, and the output is essentially in this case, it's a visual that you're able to see it and comprehend it. Okay. There are a lot of other softwares that you interact on a database, right? So when you go to the Google and search it, you're searching a software, right? It's nothing but a software. When you take a picture, send it to somebody through email or text message, those are software. Right? Pretty soon, in 3 months, the year end will come, and Uncle Sam will start looking for their share of money. So you'll utilize some sort of text preparation software to do it. Right. I don't know how many of you are gamers, right? The video games, whether it's on the phone, TV, or any of the gaming devices, you're gonna do that, right? So software is all around us, right? I don't think unless you really go out into the mountains where there is no network for that, right? You're gonna pretty much interact with the software every day.
So I have a question.
Mhm.
So can we call app as a software application?
It is software.
Okay.
We'll talk about that in a moment, right? So when you talk about, right, I say it's a sequence of instructions, right? It tells you what to do it. You follow that instructions, and that's what the computer does. Okay. So let me draw a visual for you. Okay. So when you think around computer, right? So think around it as a big box. Pretty cool. Does it have a thickness? Okay. So if no matter what computer you see it, right, it's always going to have some sort of hardware. Hardware is the things that you can touch it, right? So you're going to have somewhere something known as a hardware. Okay. On top of that hardware, there's always something known as a system software. Okay. So if you take an example, right? If you're using a laptop, it's going to be either Windows or MacBook, right? So Windows is nothing but an operating system on it. Mac OS is operating system on it. Another example is if you use the phone, if you're using iPhone, iOS is the operating system. If you're using any other like Samsung or any other devices, Android is the operating system. Okay. The key difference is your hardware is driven by what is known as system software or operating software. Okay. It is specially designed to focus on the hardware on which it runs on. Okay. And it communicates it through something known as a firmware. Okay. So all of the commands to the hardware, it's given by the system software and it happens through the firmware. Okay. So when you say, hey, I want to connect a new monitor to my MacBook or monitor to my Windows machine, right? You just connect it. At that point, the hardware recognizes that it's some external devices and looks for system software, communicates and say, hey, what do you want me to do with this new connected device? Right. A lot of times when you put your flash drives into your computer, right, you will always see it as, hey, it is trying to like it's connected, recognize that device. All of those interactions happens between the hardware and system software. Okay. Firmware is a small specialized pieces of software that runs on the chip, right? So if you look into, if you ever open up a computer and look at it, it has a whole bunch of chips into it, right? Those chips, some of them are processing units and some of them has a memory. And those memories are essentially contains the firmware to boot up the software. Okay. On top of the system software, there is something known as an application software. Okay. That application software typically communicates with the system software to do everything. Okay. Let's give us an example, right? So if you're using a phone and there is an email application on top of it, okay, that email application will be the same whether you're using a Windows machine or you're using a Mac machine all times, right? Whether it's an iOS device, iPhone, or an Android. That piece of software is something that like it doesn't require to run only on a specific hardware. It could run on any type of hardware. It usually interacts with the system software, but it's not required for that computer to work. So if I can take some apps, it doesn't have to have it here, right? I can remove some of the apps here. My phone will still work, right? Because I've not removed the system software. Right? But if I remove the Android or iOS, my device won't work.
So you
Right?
can do
Because of that.
You
Right.
can able to remove it. The
You
system-
can.
Really?
Yeah.
Oh.
It just, you just need to get a little bit more down into it, right? But the key aspect is application software is fungible. It doesn't require, right? So it's specific things that you add on top of the computer. So a lot of times, the lower two layer is known as a compute platform. So a lot of times when you go to some workplace, right, and it says, hey, what is the environment or computer environment in which you run? They'll say, hey, it's a Windows or Unix or a Mac, right? So that's essentially, it's a combination of hardware and system software. Okay, then application software is all of the productivity things that you put it on top of that. Okay, so when, let's say example, I was talking about the email, right? When you want to send an email, right, you type it up and you just click send. What happens at that point, it just communicates with the system software and says, hey, this thing needs to be sent. System software takes those information and says, okay, I need to convert that into electrical signals so that it can get it out from your phone to wherever it needs to go with over the airwaves and then sends it out, right? Same way, when somebody sends you an email or text message, right, it comes through the airwaves, right? Hardware recognizes that, hey, there is some event coming in for my particular device, right? Because all of the devices have IMEI number, right? And if you're using it a Windows, it has a MacBook or a Mac address, so Mac OS has a Mac address. So all of those things comes in here. It recognizes, hey, this bytes and pieces came. It just transfers that, gives it to the system software, which then recognizes that, hey, who the message came from, what is the content, and just wraps it up and delivers into your application software so that in your text messages, you can see it that the messages came from somebody. Okay, so that's how the communication happens across the three layers. Okay, most of your work that you're going to see, it is going to essentially focus on this particular layer called as an application software. Okay, very few of you ever will going to end up dealing with the system software. Okay, any questions? Is it clear how everything
always
stacks
start
up?
from the hardware, right?
The hardware is always things that you can touch and feel, right? But most of your work and quality assurance, you're going to do it here, right? If you're like, it's kind of a computer engineer system designer, you're going to end up working here, right? And then if you're like a hardcore software programmer who are more connecting directly to the operating systems and hardware, then you're going to work here. So it's about 95% of the software development and engineering work happens in the application.
So if you work for companies like Nationwide or Ohio Health or somewhere, you will be working with the application software. You are building the patient registration system. You are building the Epic system, whatever.
Yeah.
That's all application software.
Yeah. Somebody mentioned about Intel, right? So when Intel comes, Intel is building the hardware, firmware, right? So all of those engineers are going to be focusing on designing the chips, designing the hardware around it, right? And then people like it's Apple or Microsoft or open source Linux stuff are the one who are working in the system software. Okay. So if you have this picture clear, everything, then you can start relating it where it goes into the application layer. Okay. So, okay. That's what we talked about, right? System software focuses on communication back and forth between the hardware, right? Versus application software works more on the layer to resolve the productivity or user related aspect. Okay. And the easiest way, right? This is in the old days, if you had a hardware or laptops. The way you know if something is an application software is if you need to do it, download it from the net or use the flash drive or use the optical drives, right? Nowadays, pretty much everything is kind of downloaded from the network, right? Whether it's on your phone or it's on your computer. We already talked about it, right? Application software interacts with the system software to get through it. Okay. Now, let's start focusing on the application software. Okay. You're going to see 3 different types of software application or application software as you go through it. Okay. The first one is a proprietary software. Okay. So in the software world, depending on how you acquire the software, right? You can say it's different classes of software. Proprietary software is a software that is built and developed by a company for a specific application. Right? And you cannot use it outside the domains of that. For example, if you are driving a autonomous vehicle, like Tesla or Chevy Bolt, right? All of the software that is built for that, it runs only on those hardware, right? You can't take a Tesla software and then put it on a Chevy and say expect it to run. Right? It is designed and programmed only for that particular hardware. Okay. And it's owned by a company in the sense that Tesla owns the copyright. You can't just go and take that software and sell it to somebody. Only Tesla has copyright for that. Another example is if you are getting into a more automobile manufacturing type of things, right? So, or any of the chip manufacturing things, right? So these are big machines that are controlling it, how the chips are manufactured, right? Or how the car gets manufactured. Okay. All of them are nothing but proprietary software. Okay. The second type of software you're going to see is off-the-shelf software. Okay. So I was talking earlier about the text software, right? So you can take a TurboTax, right? You can just buy it from the store, bring it and install on your machine, right? It could be your MacBook, could be Windows, could be any other type of machines. Right? Another example is Microsoft Office, right? Or Google Docs stuff that you can just pick it up either from the net or from the store and install it. It's still owned by a certain company. You purchase it, right? You purchase the license by paying for it. But then you can just go ahead and install it and use it the way you feel it's needed. Okay. So anything that you can buy it off the shelf are nothing but off the shelf software. Third category is something known as open source software. And the way the open source software differs from the first two is it's kind of built by a company. And in order to use it, either you need to get the permission of the company, and then you have to pay for those licenses. Okay. Whereas this open source software, it's a software built by community of developers. Right? They build it and then just give it out in the community for them to use it, as long as they follow the intellectual property licenses. Okay. So one of the examples you're going to see it is Linux, right? So as you go into workplace, you'll see a lot of data centers which runs on the Linux machines. Okay, that entire software was built by community open source. You don't have to pay anything. You can just download it, it's free.
Like Google Docs as well.
Right, Google Docs is there. Now, actually, Android operating system is open source. You can just download it for free and make whatever changes you want. Okay. So, as long as you agree to certain user terms, a lot of times it's known as an open source license, a software licensing agreement. As long as you agree to that, it's free for you to download and use whatever the way you want it. You can make whatever modification you want to. Okay. You cannot do it as the first two cases, but you can do it for this. Any questions? All right. Now, now that we know what are the application software, what are different types of application software, let's look into the software architecture. Okay. And here's the definition, right? So it's nothing but essentially a structure of a system, which identifies what are its components and how they interact, those components against with each other. Okay, and what is the relationship between those components? Okay. Have all of you played with Lego? Legos, right? Those tiny things that the kids play with it, right? If you think around it, each of the Lego pieces is nothing but an element or a component. And the structure you make it out of that is a software or a Lego structure, right? Think in the same terms. In a software world, you can have multiple components, and how those components interact with each other essentially forms the architecture of that particular software. Okay. So there are a lot of things which are similar, right? So when you talk about Lego or when you talk about building a house, right? House is made up of a lot of components, right? And each of the component has a specific role and purpose, and then how they interact with the other components, right? So when you talk about the electrical system, how it is wired with the frame, right? So that everything is integrated into the house, right? So when you turn on switch, well, the wiring goes through the frame, but then there is also connectivity going into that, in that and out of the house. Okay. So let's look at the British software architectures, right? It's almost now 100+ years since the original software was built. It started in the early 1930s. So over the period, right, as we learn more and more things, we're evolving it. Think around the houses that human races have built it, right? Originally, right, you can say it's the humans were living in the caves, right? That's your first house, right? Then they went into the mud house, then the tree houses, then they went into more brick houses, more sophisticated houses, right? So when you look into the human history over the last 3,000 years or 5,000 years, right? The housing has evolved, and every time it's evolved, right? You build something completely different. Same thing with the software world. Over the last 100 years, software has evolved a lot, and the architecture has evolved a lot. Okay. Originally, when the software was involved, right, everything was a single unit, what we call a monolithic. Okay. Where when you look into the software, there is only two pieces, right? The instructions and the data that you feed to those instructions, right? So the instructions are nothing but known as code. Data is your data. Okay. So anybody has seen a movie called Enigma? No. Okay. That's probably one of the first examples of the computers. It was the movie is centered around the Second World War. Okay. It talks about how Allied forces actually decrypted all of the secret communication that the Germans were sending.
I heard about that. Yeah,
Okay. So what it was that Germans will change their decryption code and encryption code every 24 hours. Okay. So if the Allies wanted to get ahead of the Germans, they need to figure it out to decrypt those messages and understand where the next attack is going to happen. Okay. So there is a gentleman called Alan Turing, a British gentleman, and he was building a machine known as a state machine. Okay. All it talks about is how the information can transition to different states in order to get your final results. Okay, so it's called the Turing machines. Okay, his name was Alan Turing. The whole concept is based on his name, but it talks about how you can interpret or provide the data or input to that, goes through whole sets of machine instructions, In those days, it was just all levers, because there was no electronics, right? It was all mechanical levers. So it goes through it and produces a result, right? That's a perfect example of the monolithic application, right? You can't just send in data from somewhere else. You have to be physically in the room on those machines or levers in order to provide the data and then turn the levers to get the results out. Right? So code and data is on one and same place. Okay, you don't need an external information to do that. And then after the World War, right, they started looking into it, says, hey, this is a really productive way to do the things, if we can expand on that, right? So they started like it's building in, but eventually they realized it. If I have to use that in a commercial applications, I have to get it outside from a single room into more places, right? So they started coming and evolving into what is known as a client-server architecture. Okay. In this architecture, right, they just started, hey, you know what? The most expensive part is the code or the server or the machine, but it's idle for most of the time. So what if we can take multiple people providing that input and the machine can slice it and be busy at all the time, right? So on that notion, they build what is known as a client-server architecture. You will see it in probably it's still 1960s, 1970 movies, if you look into any of the banking stuff, right? So those of you who have seen it, like some of us have seen it, but some of you may not have seen it, but seen it in the movie, right? Something known as a green terminal, right? So have you ever seen the movie Ghost? Right? In that movie, the ghost, in that movie, if you see it, right, all of the theft is happening on the computer, right? It's the terminal is a green terminal.
The green screen, like.
Green screen, 80 by 25, green screen.
Yeah, like a lot of banks had it.
Right. So that's where the bank started. The bank just said, hey, you have a server, we'll connect it to different machines or client or entry points. They will enter the data. All the data will be sent to the server. Server will perform that computation and send you back the response.
Right, just like a Google data, right?
That's a lot more advanced. But you get the notion,
Right.
right? So in this scenario, let's say if I want to, like it's a deposit of money, right? I'll be sitting as a tailor. I will go to the bank. The tailor will be at the terminal. They will just enter the amount that I'm trying to deposit. It will go to the central server. Central server will accept the deposit, update my account, and send them back a response that deposit was successfully submitted, right? So same thing with client 2 will do it. Couple of things you need to start thinking around, right? So in this case, when I was doing a monolithic, I don't have to worry about any external factor. I'm giving you the data, you're processing, there's nobody else is involved at all. Right? So if I have to test it, all I have to do it is give the data and see if the code is expected as I was expecting them to behave. Right? There's no external factor I have to worry about. So if I have to test a system which is monolithic, it's very simple. Right? All I give it is input and check it whether the output is fine or not. In this case, it's a little bit different now. Because I'm connecting it remotely, right? What happens if I put the request and something happened and this connection disappeared? Where am I going to send the response? More importantly, if there are 2 customers coming in to deposit, one deposits $10 and the other one wants to deposit $1,000. You want to make sure you deposit $10 for this client and send them back that response only. Right? And you deposit $1,000 for this client. So now you have to worry about who sent me the request. Did I send the response only to that person and not to somebody else? I also have to worry about to test it. What if this connection goes away? What happens to my response? Right? I got the request. How many times I keep trying it? Right? So if I'm a software quality assurance or a tester person, now I have to think about additional scenarios than what I didn't thought about earlier, right? I still have to think about, if I give the input, am I getting the right output? But now I also have to worry about the connectivity. It says, did I send it to the right person? And is it still available, that person? Right? You don't want to go into a bank and say, hey, you deposited my money to somebody else. How many of you will be happy?
Yeah.
Right? Same thing that you need to think around, right? So that, even though the architecture gave you flexibility, it added a complexity that now you need to start worrying about and thinking about. Then came in early 80s, mid 80s, right? Where they started getting a computer to a point where it was much more affordable. So it's got out from the confines of a big corporations to small companies also, and the small clients and so, right? So they started thinking around, hey, I need to now evolve it into it. It's no longer just a client server, right? Also, at that point, they started realizing it is most important properties for any companies is the data. It's in customers' information. It's not your hardware, it's not the machines, it's the actual data, right? You can clearly see it, how Google and Facebook and all the things is kind of taken up, right? It's not their hardware. It's not their software. It's actually the data that they have it around the customer, and how they utilize that data is what it makes it more valuable in property. Right? So they started thinking around, hey, we need to break it down. Right? So data is important, but the same data can be used by multiple applications. Right? I can do a customer related data to say it's what his customer's account look like. Or I can use the same data to say how much money was deposited in this particular branch. Right? Two different views. It still runs on the same data. Right? And then they also just read it. Not only I have to worry about the application, but how I'm going to present it. So if I go to a tailor, right, they pull out of my data, the screen and the presentation they're going to see it is going to be a little bit different than if I go into essentially my own laptop and log into websites and see what is my account looks like. Right? So they look into it, say where my presentation is going, what device it's going, right? Because if I look into my computer, right, it may be like it's a 13-inch screen. Right? If they may go into a tailor may have it like 20-inch screen. Right? So I need to start thinking around presenting my information appropriately. Okay. Right? So my presentation here is going to be how my information is getting presented. Right. Right. Because on my mobile, I may just present only a small set of information versus I may present big set of information if I'm logging in from computer. Okay. So they talk about data. There is an application that runs on top of it, and then how the users access it or present that information. With this architecture, right, just like it's the client server, there is additional complexity comes into play. If I'm writing a data from an application, I need to make sure that data is written or retrieved appropriately. What if this connection goes down? How do I do that? Same thing goes from presentation to it, right? So if I go online and say, I want to transfer the money from this account to that account, right? It's going to go to the application, right? Application is going to perform that. If any of those connections here, right? What happens is, think around it, right? Transferring is nothing but withdrawing from one account and depositing into the other account. What happens if I withdraw it? I lose the connection. Database goes down. What do I do with that withdrawal? I can't deposit because I can't connect it. What happens to that? Do you want to lose your money? How many of you will continue to do banking with that bank? Right? So the complexity gets involved as you evolve the architecture, as you add another component, you have to start thinking around different additional scenarios that you need to look into it validate and make sure system still performs the way it is expected in the right conditions. Okay. Then the internet working. 1990s. Right. When the Google came in, the likes of Amazon came in, right? And all of a sudden, the world has changed. Earlier, if you go to the bank, right, there will be only like it's 5 tellers. So you have only 5 connections at a time. Right? You go into the big corporation, I have only 10,000 users, so only 10,000 people will be at the time. It's more easier. But when you go into internet, now you have hundreds of thousands of customers accessing the same information at the same time. Right? So you need to start thinking around architecture and says, how can I address hundreds of thousands of requests at the same time? Okay. Before I do that, I want you guys to think around in Notion. Okay. I'm going to try to get the thickness.
Popping up.
I was trying to like it's get the thickness.
Yeah.
This is too thick. I want to like it's get down a little bit thinner.
We'll figure out in the break.
Okay. Oh, there it is.
Yeah. there you go.
Okay. All right. So I want you to imagine. I'm going to give you a quick 5 minutes computer architecture notion. Okay. So when you look into any computer, it has something known as CPU or central processing unit. Okay. So when you look into it, Apple just came out, right, with their iPhone 15, right? They talk about the chips and the processing power and all of those 9 units, right? It's not, CPU is nothing but the brain of the computer, if you can think about it. It's known as central processing unit. Okay, that's where all the computation happens. Instructions. Okay, and typically those are like it's nowadays. There are 16 cores, 18 cores, 32 cores. Essentially, it's 32 simultaneous brains working, if you think around that way, right? And typically those works on something known as like 3 gigahertz, 5 gigahertz, right? So it performs computations in the matter of nanoseconds. It's that fast. Okay. Associated with that is something known as a onboard memory. Okay. So when your CPU wants an instructions, right? They look from a memory and that memory feeds them. Here's the next instruction. Here is the next instruction. Okay. And when they perform the computation, right, they get said, here's the output. They just try to put it out, right? So those input and output needs to go from some sort of memory into those processing powers, right? So therefore, there's an onboard memory on the chip itself.
Is that a RAM or something?
No.
Or different RAM?
There is on the chip itself,
Okay.
right? They also tell it's a level 2 memory.
Okay.
Okay. So within the same physical die cast or physical piece that the CPU does it has a very small amount of memory. Okay, that's where all that comes in. And then there is also something known as a RAM. Okay, which is a read-only or random access memory. That's something that when you see it is like it's hey, it has a 4 gig RAM, 6 gig RAM on those processors, right? So this onboard memory, it's typically on the range of 4 to 8 megabytes. Okay. If you think around if you take a 25 megapixel picture, that's usually like it's 30 meg file. This is literally 4 to 8 meg. RAM is typically your 4 to 32 gig. Okay. The way it happens is every time CPU needs an instruction, they don't go to the RAM. They just go only to the onboard memory to get that instructions. Okay. And then onboard memory, if they run out of the data or they need to feed it, they get it data from the RAM. Okay. Now, the memory which is on board, which is in the same die cast, it usually performs in the matter of nanoseconds. Same speed as your CPU, right? Because it has to keep up with the CPU. That's why it's on the same die cast. It uses at the same speed. Okay. So this onboard memory is somewhere in the 10⁹ speed. So if you think about it, right, it performs 1 billion transactions a second. Okay. RAM, it's typically 40 to 32 gig, right? So it's a bigger pool than that, right? In this thing, it's typically anywhere between 10⁻⁷ to 10⁻⁻8 nowadays with the speed. So it's about 10 times slower than the CPU, 10 to 100 times slower than CPU. Okay. But obviously, like you can't fit everything in 32 gig. You need a bigger space, right? So what you're going to see it in the computer, they have something known as a hard disk. Right? Even on the phone, they say it's a 128 gig phone to 56 gig phone. They're nothing but the hard disk. Right? So whenever the RAM runs out of space, whether to read it from or write from it, they go to the hard disk. Okay. Hard disks are typically anywhere between 500 gigabyte to a terabyte or 2 terabytes, right? So roughly this is about 2 terabyte type of hard disk. Okay. This thing, if it's a magnetic, it's only like it's a millisecond, which is 10⁻⁻⁻⁶, right? This is roughly between 10⁻⁻⁴ to 10⁻⁻⁻² speed. Okay. So it's about 1,000 times slower. Right?
Yeah.
Goes at 1,000 times slower. If hard disk doesn't have enough space, they go into what is known as an optical drive. Okay. These are typically only in milliseconds. Okay.
Even slower.
Sorry, this one is millisecond is 3. So this one is typically like it's tens of milliseconds. Okay, but this optical drives can store in the matter of what we know as petabytes, which is hundreds of terabytes data. Okay. So now you can see it, right? So it goes from onboard cache, right, to a RAM, to a hard disk, to optical drive. And if the optical drive is not sufficient, right, now they offer is, hey, I'm going to offline the data and archive, keep it in big storage. Okay, so they go to offline storage. Okay,
Offline storage, something like external hard drive.
It's sort of external hard drive, right? But you have to connect it and like it's retrieve it, right?
Right.
In a big companies and the data, it's kind of offline storage. Essentially, they write it into drives, take it completely offline, put it into storage.
Okay.
And then when you need it, they just take it out, put it back online to read it, and then only you can access the data. Okay. Now, when you look into it, right, the speed, every time an arrow goes from a left to right, the speed drops by 100, right? So your normal reaction is, hey, why don't I put everything into a cache? So I never have to worry about it. Everything is very fast, right? something known as a cost comes into play. Okay. The cache, if you're trying to get it, it's $100 a megabyte. Okay. When you go to RAM, right, you can get 32 gig RAM nowadays for like it's kind of $60 to $80, right? So this goes into $1. When you go to hard disk, right, the cost is kind of comes to 10 cents or some cents. When you go to optical, it's typically less than that. When you go offline, it's essentially a fraction of a cent. Okay. So the price comes cheaper and cheaper, right? Also, the architecture, you cannot put forever that much memory into the cache, right? So you have to start balancing it as you go through it into, right? Now, the most performant is the cache, right? So when you go into the internet world, when you have hundreds of thousands of customers accessing it, right? Hey, hundreds of thousands of customers, it's probably a huge amount of data, right? So if I'm looking, let's say I'm a photo processing site and 100,000 customers are accessing their picture at the same time, right? Think around how much memory it'll require, and each picture is 30 meg picture, right? You can't fit everything into the cache. That means you need to figure it out to move something in the RAM. Sometimes the RAM is not sufficient, then you need to get it to hard disk, right? So you have to trade it off. As the number of users comes in, you need to start thinking the architecture, right? So traditional architecture, where you're doing it, hey, I'll just have a hard disk, put a RAM, get the data presented. It's good for 10 users or 100 users that I can accommodate it. But when I have hundreds of thousands of users, I can't accommodate. So I need to think a different architecture. So that's where they started doing it. Okay. So this one is an extension of 3-tier architecture. You look at the bottom layer. Okay. It's broken down into 2, right? So if you remember, there is a data layer, right? There's a data tier. I'm breaking this data tier now into 2 tiers. Okay. One tier is I'm going to keep it into my RAM or cache memory. Other tier I'm going to put into sort of hard disk or database type of thing. Okay. And I'm going to keep it only those who are current active customers into it. Anybody who is not active, all of the data I'm going to push it to that. Right? So when you have hundreds of thousands of users accessing it, or millions of customers, you're not keeping all data into the memory. You're keeping only those customers who are actively performing transaction at this point into the memory and push everything else down into the database, right? So Amazon pulls your data into the memory only when you are performing a transaction with them. Once you're done with transaction, you're logged out. They take that information and push it back into the database.
So it'll happen automatically. Right?
It'll happen. That's the architecture behind it,
Okay.
right? You don't have to worry about it as a user. But if you're testing the system to make sure everything is working, you have to worry about that, right? You need to say, hey, what data is in here? What data is pushed out here? You need to test it. Right? Because that's why when you log in first time into any of those Amazons or those kind of systems, the first time, if you notice, it takes a little bit of more time. It takes a fraction more. The reason why it takes a fraction more, because it recognizes, hey, I don't have you in the memory. You need to fetch all of your data and bring it. Remember, what is this speed? Milliseconds. So it's going to be slower than this speed, which is nanosecond. Right? So I'm going to take that data and put it. Now, once it's in here, it's a lot more faster. Every subsequent transactions or actions you perform, it's very quick. Okay. So I need to worry about managing that work. So that's one thing happens in the architectural world. The data is broken down into 2 tiers. Now your application layer or business process layer is still the same. Okay. But now your presentation tier, or presentation layer, it's gonna be broken down into different. Right, because I don't know what user is accessing it from, right? They could be ordering from the app. They could be ordering it from their website, right? Or they could be calling somebody and ordering from there. And then I may have a customer service rep, which is like, it's kind of doing it on their behalf, right? All of those things are different user interface layers, right? Because my app is different than my phone, or like it's a desktop application, right? But when you look at the data is still same, you're still performing the same way transaction. You can still view all of your order on your phone, or you can log into and do it. When you're logging into the phone, the way the order is presented is a little bit different than if you logged into your computer and presented, right? So they break it down, essentially the presentation layer now into two. One is presentation layer, another one's user interface layer. Because my form factor is going to be completely different every time I access it. And based on that, I'm going to present them different sets of information or subsets of information mainly, right? Because when you're looking into from your laptop, you have a lot more information. But when you're looking into that, you have only small sets of information that is presented to you. It's still the same order, just presented in a different way, and deciding it, hey, you know what, you're currently accessing from the phone app, so I'm going to present it only this sets of information. Right. All of the data is still the same. So it's something known as a model view controller. It just says, what is your view? What is the model? And how I'm going to control that data to be presented to you.
So presentation layer is some kind of user, right? Whoever use the application.
The UI layer is how the information is getting presented.
It's essentially code.
Right.
Yeah, yes.
This one is essentially behind the scene. You're not seeing it,
Okay.
but it is presentation layer of how I'm presenting it.
Okay.
Business layer is essentially where the logic happens. Did you order? Is your order is in processing? What is happening? Did you do the payment? Right? Because you can't move the order unless you perform the payment. So all of those logic happens in the business layer, and your data is data. Right. So that's the architecture you're going to start seeing into as the early 2000 when they started coming into a massive scale. Okay. Then they started realizing it. Till that point, all of your interactions were confined within a company's world. Okay. But when the Amazons came in, right? Typically, before the internet world, right? When you want to go ahead and purchase a book, you will go to the store, right? You will pay through your credit card or payment card, right? And then the store will have a dedicated network going to their bank and says, hey, I want to validate this, or going to the Visa or MasterCard network and says, I want to validate this thing. Okay, they will get that payment validated and do it. I don't have to worry about going outside, right? Because I have a contract with my bank to get all of that. I don't have to worry about anything else. But as the things come in an internet world, right? Now I know I can't control the form of the payments that the people are getting. I don't know which company has issued or which bank has issued their credit card. I don't know what is their limit, right? I don't have any other ways to validate it. So they need to start getting into, hey, I'm in Amazon. I can't have a bank, right? Because banks are the one which are processing everybody's payment. So if I'm giving them an opportunity to log in from their computer and do that, whatever the payment method does it, I need to go to somebody and get that payment as verified. That is that truly a right credit card, or is it fraud, or it's invalid credit card number, or they're out of the limit and they're not allowed to purchase anymore, right? So as an Amazon, I need to go to the bank to get their services. If somebody gives me credit card, is this valid payment? And are they allowed to make this much payment, right? So now I'm going outside the bounds of Amazon, going into the bank. So I need to go ahead and interact with the others, right? So that I need to get the payment service. Okay. Another aspect is once I get the payment, I need to ship that thing. I'm going to ship it through, let's say, FedEx. right? FedEx will give a tracking number that I need to give it to my customer, says, hey, I shipped your item. Here's the tracking number, right? But I'm not gonna build the whole shipping. Well, FedEx is doing shipping. They knows when a package moved from a plane to the local distribution warehouse, then it got into the truck, which then it got into my house, right? So the whole journey, I'm not tracking it, FedEx is tracking it, because they have the logistics stuff. But I want to show it to the customer where their package is. That means I need to interact with the FedEx. To say, here is the invoice, here's the shipment. It's going to be delivered to your warehouse and take it from there to deliver to the customer. That means I need to now interact not only to the payment service, I need to get the shipment service to interact in order to give my end-to-end user experience. Right? So because of that need, the service-oriented architecture evolved. And then they said, hey, you know what? The presentation layer is still the same, but I need to now worry about orchestration layer. The simplest way to think around it is if you go to the restaurant, right? Let's say you go to the McDonald's, right? You see it on the menu, right? You order certain things. When you order certain things, it kicks off the process, right? So it just, as soon as you enter the order, right? Somebody in the backside of the store is looking into it and says, oh, somebody ordered this, I need to start making this. Once it's made, they give it to you, right? And then the server gives it to you, or you pick it up yourself, right? So you order it, you pay for it, somebody prepares it, and then you get your food, right? That's nothing but an orchestration, right? 4 steps. Same thing when you go to the Amazon, right? You look for an item, right? You go through it and says, yes, this is the item that I want to purchase. You put it to your cart. Then you do the payment, right? Once the payment is done, it goes into the shipment. The item gets it shipped, picked up by your carrier, whether it's a FedEx or UPS, whatever that. They take it and they deliver it to you. Right? It's nothing but an orchestration layer. Right? So what are the steps happening in order to fulfill that service? Okay. Then underneath that, you can go say it's, hey, it's going to have a different thing, right? So ordering, so when you're trying to let's do an order on whether it's on a McDonald's or when you're trying to order it on Amazon, right? Ordering is a service. That service may in turn use other service and say, hey, search, because I'm looking for a book or I'm looking for a movie on Amazon, right? I'm searching on it, it just presents me, right? And then it looks into it and says, oh, I want to buy this, now let me put into it, right? So that's part of your ordering service. When you do a checkout, right, you take everything from the ordering service, apply any discount or whatever that you need to do it, identify what payment is, then present a user to do the payment. When a user performs the payment, you need to go to whatever your payment gateway is, validate that payment, get that payment, come back. That's your payment service. Once it's finished payment, right, you send it to the shipping. Shipping guy says, okay, here is what they ordered it. The payment is done. Here is the address where it needs to go. Oh, guess what? Here is the shipment option that's selected. It's a 2-day priority, overnight. Bring it whenever you can bring it to me, right? Different types of services based on the payments that you've done it. Then you take that and say, okay, now I need to create a package and I need to put a label on it, give it to FedEx to ship it. Right? That's a shipping service. So you're going to have services underneath that, right? All of them, like it's kind of, when you go to Amazon, right? It happens instantaneously, right? So all of them are programmatic interfaces going to the different services and accomplishing those tasks for you. Underneath those, right, you will have your product inventory, right? Your product description. Because when you go to look for a product, right? Let's say if I search on a phone on an Amazon, right? It brings me thousands of entries, right? It gives me summary, right? So it's a component. It goes, looks into my product catalog, and gives you everything that matches that description or the criteria that you asked me for. Brings me that. Then I can click on it. I want to view the detail for that product, right? So it goes into that. But when you try to order it, right, it needs to make sure that they can fulfill your order, right? So they go into inventory component to say, can I ship it or can I provide that? You see how all of those layers are now decomposed underneath that? And then components underneath are running with the applications. You may have inventory applications or your vendor applications where it's like, because we can go to Amazon, right? It's not only Amazon which sells it, it's the third party which is also sells the software, right? So they're connected through all those application layer on that. Okay. And then obviously all of those things needs to work seamlessly, right? So you have something known as enterprise service buses, which kind of sees where the transactions are going. So you can monitor it and says, is the things flowing? If things is kind of not working, it alerts it to your management layer, right? Where each of the have an operation centers, which is looking at all those things and say, hey, this is not working, or there's a breakdown here. We need to work around on getting those powers. Okay, so that's your service-oriented architecture. So as things started evolving it and the internet become a more prominent, people are providing essentially products which goes across multiple services, multiple corporations. That's where the service-oriented architecture came into play. Now that doesn't say that you always have to have an external interaction to do it, right? You can still build a service-oriented architecture for all of the application and services you provide within your corporation.
Just to add on that, right? So when the company has, the application has this architecture, right? How many QAs they will have working on this type of application that includes service-oriented architecture? Any guesses from anybody? The companies like Amazon, how many QAs they will have? Probably 1,000 QAs they are testing.
Because at each layer you need to worry about, right? Validating it, and overall product you need to validate it.
So there is not one person job, okay, to test, but you need to get a bigger picture to how the architecture is laid out. You might be responsible for a small component or small systems, that's part of it. Okay, so but there will be 1,000 plus QA working on the testing, just on the testing aspect.
So, and we'll look through it, right? Because think around from a monolithic to now service-oriented architecture. How many layers in order to fulfill one request? You have to go across 4 layers to get that data, right? And every layer that you add to it, there is complexity, availability, response time, how quickly it gets it, address it. Is it giving me the right data? What if that is not available? I'm getting an error message. How do I deal with those error messages? All those testing needs to happen.
It's kind of process.
It's kind of process. Yeah. Right. Then Mr. Steve Jobs decided to make it your cell phones much better, and the whole world changed. Right, back in 2007. So I don't know how many of you know it, but cell phone existed before iPhone came in.
Yeah.
Even the smartphone existed before iPhone
I
came in.
use that.
Right.
What we used to call was bricks. Right? Has anybody used the HP phones? The bricks?
Nokia.
Nokia, I think- I think
Nokia had it, but the HP were more heavier and bulky ones.
I use Nokia,
Right.
but not.
Yeah, but I'm talking about the smartphones, right? Where you are actually access the data and corporate stuff, right? So the BlackBerries existed, the HPs of the world existed before that, right? But with iPhone, what Steve Jobs changed things underlyingly is the ease with which the user interact with it, right? So it became a much more usable and intuitive interface in order for users, right? And that picked up the pace at which people started using mobile phones to perform their transactions and their business. Okay, so now think around this world, right? Everything is connected. You don't have to worry about, right? Whether it's out there. Mobile world, things changes. You're not always connected. If you're driving it at 70 miles an hour in Montana, chances that you're not going to be continuously hitting the tower, right? You're going to lose the connections. What happens if you're performing any financial transactions during those connectivity loss? What happens to your transactions? You need to start thinking around those. And also, you're not sustained connection. When you move in, your actual connection moves from one tower to another tower to another tower constantly, right? You're not connected to the same tower. You're going to different wireless towers every time you connect it. So you need to start thinking around, what if I'm not always connected? I'm going to lose the connectivity and I'm going to gain the connectivity. How do I deal with that? Right. So that's when the mobile application architecture came in. That I need to start thinking around maybe keeping a local copy on my phone. Right. So when you're sending an email, right, you get it, all the emails till the last time you're connected. Right. You can still type in email responses and everything, even if you're not connected. It'll still take it, it'll still put it in draft message. Right. And the moment you're connected to the network, then it just says, okay, let me now send all of the messages. But it has to think around it, right? It doesn't send all of your messages. It sends it only from the last time I was connected. And what has changed since then, it does it, right? So now I need to start thinking around the state mechanism, keeping it within the phone. What was the current state? When I was last connected? And then when I connected again, I need to think around synchronizing with it. From that point to this point. Right? And always, you may not be connected all right. You may be just connected only for a few seconds. You went through halfway, the other half emails are still not sent. So the next time you connect it, it doesn't start from the stop. It just says from wherever I left off from that point onwards. Right? So now I need to think around the state and managing it here, state and managing this thing here, right? Because this could still be a service-oriented architecture implementation. But now I have to worry about, I have to worry about your state session and when you connected last and what data, the delta has happened since then that I need to push it here. Right? That means if I'm a quality assurance person, now I need to worry about those scenarios. I need to simulate those scenarios and test through it. Right? Life was so much easier when it was monolithic, right? But that's where you need to think around it, right? So as the complexity adds, the more and more you need to think around it, the more and more connection when you do it. Same thing, right? When you think about humans were living in the cave, life was simple. Go in and out, that's it. There's nothing else left. Right? There's no heater, there's no cool. Right? You need to actually build up a fire if you want some warm air. Right? Versus if you go into this high-tech, modern, all connected houses, right? You have all of your electrical connected to the Wi-Fi, connected to the internet, giving you all of what's happening in the world, what's happening in temperature, right? All of the wood connections connected to the sewage systems, connected to the infrastructures and that, right? A lot more connection points, right? Something goes wrong, you need to work through that. Same thing when you do it like mobile and service-oriented application, right? A piece goes wrong, you need to figure it out, what needs to be addressed, right? But you need to identify as you go through it, what needs to be done. Okay. All right. So let's do one thing. We are around an hour and 20 minutes into it. Let's take a quick 5-minute break. Okay. And then we'll it's kind of restart it back in 5 minutes. Okay. So if you're looking for the restroom, it's right around there.
On the right side.
On the right side. On the right side. Yeah. Okay. Huh?
Yeah. Water is in there.
So there's a kitchen here.
The water bottle, you can take a water bottle. No, I mean, I know
How many bathrooms do you have? How many
With one.
Just one.
Yeah.
Let's Okay. So now if somebody talks at high level, like what is service-oriented architecture, what's multi-tier architecture, you should be able to tell it, hey, it's the three components that comes into play to bring it together a solution. Right? So those are different software architecture, right? But at some point, somebody needs to utilize those architectures and build a software on top of it, right? When you think around, you have a great blueprint on the paper, but somebody needs to still convert that blueprint into a house, right? And what is the process they go through it in there? Right? It's essentially a development cycle, right? Of how the house is getting built. Right? Same thing goes from software development, right? There is something known as software development lifecycle. Right? How the software gets built till how do you retire all of that, right? So that entire process is known as a software development lifecycle. Okay. So think around. No. Okay. Oh, the circle disappeared.
Oh, disappeared.
Yeah, it looks like it disappeared. Okay. So here's what I'm going to do. Okay. Think around. Let's start. Forget software for a moment. Let's say you want to build a house. Right? Let's think around the whole process that you will go through. Right? What is the first thing you want whenever you say, hey, I want to build a house? What is the first thing you're going to do? Plan, right? So you're going to start planning for it. Right? And says, hey, I want to build a house. Right? First thing you're going to do it is, do you have money to build a house?
Yeah.
Well, how much?
Right?
Yeah.
What kind of house you want it? Right? Why you want to build a house? Right? So it's not only just the money, but why do you want to build a house? Versus why can't you just go rent it to them? Right? So that's all part of planning. Right? Do I have money? Do I have a reason to build it? And do I see a value in building it? Right? That's the planning phase. Okay. Let's say you have money, you have decided like it's worth it both building a house. Right? What is the next step?
Designing.
Do you go directly into design?
No, I think.
Look for land.
You analyze, right?
Analyze.
Even before looking for a land, right? You start figuring it out. What kind of house I want?
Yeah.
Where do I want it? Do I need it in the downtown, in the multi-story building? Or do I want it into a suburb, standalone house? Or do I want to go into rural area and I want a big farm with the house? Right? So I need to start analyzing,
Yeah.
right?
I think like I want like 3-bed or 4-bed. That's
Right. What kind of things I wanted in the house? Right? Where do I want it? What kind of things I wanted? How big I want it? What other kind of things comes into it, right? So that's the next thing I do it. Once I have that, what is the next step I do?
design them.
Then I do a design, right? So then I'm gonna look into it as, okay, I want a house into, let's say in a suburb, right? And I want a freestanding house with some backyard, right? They're gonna say, okay, great. You want 2-story, 3 stories, 1 story, how many bedrooms you want it, right? You start designing it. Right? What happens after the design?
I think implementation, like, I think this step is developer maybe.
Forget about software, I'm talking about the house. Don't even worry about that. Once you do that, what do you do?
Start building.
Start building, right? You get a contractor and says, okay, design is nothing but your blueprint. Now take the blueprint, convert it into a house, right? So they're gonna go build it. Okay. What happens after you build it?
Yes.
You test, right? You inspect it,
Inspect, yes.
right? So you can say, hey, is it truly a 4-bedroom that I expected? Is it 2 floors?
Right.
Right? Does it have the right plumbing? Does it have the right electricity?
Right.
Right? Does it have right venting, air circulations? Has the right number of windows? Does it have the right flooring? Is the right carpet? The whole 9 yards, right? You're gonna test all of that. Once you finish testing, what do?
Start
Stay
living, start living.
No, you accept it, right?
Accept.
Yes, it is what I was looking for it. You build it according to my specification. I tested it. It's good. I'm taking it now. Right? That's when you go at, like it's if you're done in anything around housing here, that's when you go and close your deal, right? That's when you give out the money.
Concept, right? You walk through.
Walk through the concept.
Okay, so
Right? So you do an acceptance, as part of acceptance, right? You do a walkthrough, making sure everything is there in place as you expected. Okay? And then once it's done, then what do you happen? Then you start living, right? And you go into maintenance mode, right? And then if you want to expand it, let's say I want to now build a patio or build a sunroom. You go through the planning phase, the whole 9 yards, right? So this is my cycle for building a house. Right? Plan, analyze, design, build, test, accept, and maintenance. Right? Keep going into that cycle. Till the point that I decide I don't want to live in that house anymore, and I just want to sell it. Right? You sell it and you move out, right? You're out of that software or like house building lifestyle. Now think around software the same way.
Right.
Right? I need to plan first. Why do I want to build software? Why do I want to automate it? Why can't I just do everything manually? Right? Why can't I just, somebody gives me a cash, I walk into it, pick the book, give them a book. I don't need any software. I can still run my business. Right? It gets harder if I want people from outside my location to start buying the books from me. Right? Then I need to start planning. Hey, I want to expand my business. I want to add some more productivity, more efficiency into it. Well, let's build a solution for it. So is there a valid reason? Right, I want to expand it. Do I have the money to build the software? And do I think I can get my money back by selling enough books to cover up for that expense that I'm going to do it to build the software? If the answer is yes, great, I'm ready for the plan. Right? Then I go and say, okay, what kind of software do I want to build it? Right? Where it needs to be accessible from? Who all should be able to access it? And what all it should contain, what features, capabilities it should contain. Right? That's my analysis phase. Once I analyze all of that and say, okay, now I need to have somebody build for me. Either I'm going to hire a software developers to do that for me, right? Or I'm going to outsource that to some firm and say, go build it for me. Here's my requirements. Go build that. So they're going to come up with a design. Okay, if you want this, you need to build it this way. This is the architecture needs to be done, right? Whether it's monolithic or whether it's a mobile or somewhere in between, service-oriented architecture, right? That's what I'm going to look for. And says, this is how we're going to build this software. This is how long it's going to take me to build it. Okay. Then you give a go ahead, just like, right? You give the blueprint, you got the contractor, right? And says, it's going to take 8 months to build your house, right? And it's going to cost you this much money. That's what the designers are telling you, right? Based on this, if you want this kind of features and capabilities, it's going to take this much time. It's going to cost you this much money. You good? Yes. Give me contract, let me build it. I'm going to start building it. Right? And as I build it, I'm going to test it. Does it meet those features and capabilities that I was looking for? Right? Yes, it is performing the way expected. Then we'll look at it as, okay, is everything is fulfilled? Yes, I'm going to accept it. Then it's going to go to maintenance.
One question. So when you build a house, you like at the beginning you need like 2 bathrooms, right? So after building it in the middle, like later, you wanna add one more button. So in the software, so can you do that? Maybe you can add a production part, like whatever is an inventory, a payment method. So can you start with like basic first,
Yeah.
and then later you can add it, right?
You can do that, right? So essentially, my initial requirement is just to have a cash payment rule,
Right.
right? I can do that. Then the requirement is, hey, I can take it credit cards. The third one, I can just say, hey, I can take it electronic payment like PayPal or Venmo.
Right,
You can do that. You can build it incremental payment methods,
okay.
right?
So you can build it from like basic cheaper model and then you can.
Yeah, you can do that,
Okay.
right? This thing.
What I was gonna say, that I remember as Amazon started buying books from.
They started only with the books.
Started in the garage, that you buy books, and then I would just take my book and go to them, they would give me like $30, $10 for 120 book, and I'll be fighting with them. Amazon when it started, it wasn't like this, and
Yeah.
we found a need and it, became.
It became now anything and everything, right? In the US, you don't even do a bill payment from the Amazon, but there are a lot of countries in Asia and Africa
Yeah.
who does it, everything, the bill payment, everything is from Amazon. Right? So it's not only just a book or a storefront that I can go do it, right? It has a whole bunch of services that I can do that completely from this. Right? It's all incremental. So. Right. Good with that?
Yep.
Software development life cycle?
Yep.
Okay. So think around building a house, right? You have a design in place. You go to 3 different contractors. Do you think they will build the house exactly the same way? They may have different mechanism, plans, right? They have different execution. Somebody would say, hey, you know what? I'm gonna put up the whole frame, foundation and the frame. And then I'm gonna like essentially worry about like it's putting the air circulation type of vents and everything, right? I'm gonna cut the holes after I put everything and do that. But somebody says, no, you know what? I'm gonna put the pipes in the frame as I build it in order to essentially identify how the air circulation is gonna happen, right? But somebody says, you know what? I'm gonna put the frame, pre-cut holes and everything in place first before I run the air circulation ducts and pipes. Right? All can use a completely different ways to do it. Right? The same way. In the software development world, right? There are 3 different ways you can build a software. Prominent, right? There are many ways, but there are 3 different ways, right? In those talk about the different ways you can have an SDLC lifecycle. Okay. The first one is Agile, right? Where you build incrementally. The second one is known as a RUP, or Rational Unified Process. It's typically used for big projects and a big activity. Okay. And the last one is what is known as a big upfront design or waterfall method. Okay. So there are 3 different ways you can build a software. Okay. Let's talk through each one of them. Okay. The first one is the Agile development methodology. Okay. So I gave all of you guys an example, right? At the end of the year, Uncle Sam wants the big cut of their own share from all of you, right? Through a text, right? So let's say you want to, like, it's come into the market and said, you know what, we will build our own text software and sell it to the people. We want to be a competitor to TurboTax or TextCut or H&R Block. Okay. Now, if you look at it, right, the tax software itself, like the whole rules that the government and IRS has set it up for filing a tax, it's pretty huge. In order to build a software, right, you need to think a lot of things, like it's, can you do an easy filing? Can you do an itemized filing? Can you do a single filing? Can you do a joint filing, right? Whether you have a federal business or you have a local business, right? Depending on that, you can have a business component into the tax filing. Also, not only just that, right? You have a state taxes. So state of Ohio has their own tax mechanism on top of the federal tax mechanism. right? And depending on the county, right, you may still have local taxes. City of Columbus or Regional Income Tax Authority, right? There are a whole bunch of other tax thing comes in. So if I have to build a tax software, right, there are tons and tons of things, right? It's not easy. It's probably gonna take me years to build that software. Right? So I can take an approach and says, you know what? Yes, I'm gonna take a build many years, right? But I'm not gonna worry about building everything upfront. Right? I'm gonna say it's, you know what? There is probably 5% of the US population which does nothing but 1040 easy. Simplest form of the tax return. So I'm going to build a tax software that initially I'm going to focus only on them. Right. So I don't have to build a lot of complicated calculations. Simple tax table, convert it, give a user interface, and then I'm ready for it. Right. Then I'm going to say it's okay, now that I have an easy, then I can add it and say, okay, I'm going to have a standard tax return. No itemized deduction, nothing, right? The standardized tax on top of the easy. Then I will take it that and says, okay, now I have standardized. I can have it a single standard tax filer. Then I can have a joint tax filer. Then I can have a head of household tax filer for standardized, right? I can add a complexity at a time. But I'm taking a big problem, breaking into small problems, and addressing only that piece to begin with. Okay, so when I design and implement and analyze it, I don't have to analyze the whole world. I'm taking a small piece, analyzing only that piece, building that piece, and delivering that piece. Right? That's called an Agile methodology. I'm going to slice a user value of the whole thing, but it's still end-to-end value. So it's not, hey, I'm creating only tax table. Well, that's not used for anybody. I can't sell that. But I can take it that simple, standard, easy filing and sell it to that 5% of the customers and start making a money. Get the feedback and build on top of it. Right? So I have a vision. I want to build a tax software. I'm breaking it into small pieces called iterations. Right. In an Agile world, these iterations are typically 2 to 4 weeks, no more than 4 weeks. Okay. So I'm taking that pieces and says, okay, now that I know what first slice I'm going to tailor, I'm going to go through the normal life cycle. But I'm going to perform design and analysis. I'm going to do an implementation. I'm going to test that. And I'm going to deploy. And then I'm going to go ahead and get into the second cycle. The value here is at the end of every cycle, you are actually releasing a product that somebody can use it. Or you can sell that product and start making money. That's called an Agile mindset. Okay. In this case, I'm going the whole life cycle, including testing in that particular 2 to 4 week period cycle and delivering it. The second way I can do that is known as a RUP methodology, a rational unified process. Okay. Now, this is typically used for a large scale projects. So I'm kind of a lot more science and a space buff, right? So if you look at it, right now, NASA is going to try to put humans on Mars, right? It's a big project. You need to think it a little bit different in that project, right? You're the first model. How am I going to take it the people from here to Mars? Right? So you start building the requirements. And says, you know what? I needed a way to lift off the people from the Earth to Mars. As part of that, once they get out of the low Earth gravity, they need to figure out how they're going to navigate from here to Mars. Once they reach to Mars, I need to think around how they're going to land on the Mars. Right? Then I'm going to worry about how they're going to survive on the Mars for whatever duration they are on the Mars. Then how I'm going to bring them back, because I can't have it a one-way journey and say, forget about it. Right? I have a huge infrastructure on Earth. that I can do that. But when I go to the Mars, there's no 5,000 people helping it to build me a spacecraft. Right? I need to figure out how I'm gonna lift it from the Mars, bring them back to the Earth. Right? So it's a huge complex project. That involves many things, right? It involves a propulsion systems, it involves life support systems, right? It involves navigational systems. There are multiple pieces into it, right? So I may have to visualize the project first, right? So in those scenarios, right, my business modeling and requirements going to be heavy in that particular phase. It's not going to happen overnight. It's not going to happen every 2 weeks increment, right? Then I need to think around it is I need to elaborate or prototype all of those things. That means I need to build an engine to take that. I need to test that engine. Then I'm going to assemble that engine into the rocket to shut it up, right? I'm going to put the human crew systems. I'm going to put a life support system in it. I'm going to test all of those integrated, right? Then I'm going to put it on the top of the rocket, test it out whether it can lift it up or not, right? So that's where you're going to do an analysis and design a lot of those things. You're going to start implementing some of those things, right? You're going to create an engine. You're going to implement how you're going to assemble those things, right? Then I'm going to take it back and say, it's okay, I'm going to be in a construction phase. So now that I figured it out, everything works individually fine. I'm going to construct them all together and build and lift up them, take it them to that. Right? And not have everything into place. Like, for example, if you look into it, right? How NASA took it, step-by-step approach, right? You build the engine, and then you put the engine on the rocket, lift it up, says, can it leave the Earth's gravitational system, reach that. Then you put a crew living empty prototype on top of it, lift it up, can it get out of the ground? Can you get out of the Earth's gravity? Right? That's why they moved the Artemis mission last fall. They sent it to the empty crew with the dummies all the way to the moon and brought it back. Right? Now, next step is they're going to send a human. They're not going to land on the moon yet. They're going to send a human, go around it, and come back and says, can I test it all the other systems? Then they will do a third prototype to land the humans on the moon. Right? So that's where the implementation and construction is going to come. Once all of that happens, then you're going to put it into production and deploy. Same way goes into the software. Think around it. Everything that I mentioned it involves a software with it. Right? So they're going to construct that software. And eventually all those software needs to be integrated and communicate with each other, right? So when my propulsion system is going on, I can't shut down my human support system. That still needs to talk about it, right? When I eject it, right? That's why they have it, like if you look into the space shuttle, right? They have 3 different strips around the world in case if the liftoff goes bad, where they can actually land that shuttle. Right? There was one in Africa, one in California, and one in Florida. It says those are the 3 places. Something goes wrong, it's going to land one of the places. Right? So that's what the configuration and change management. So you can take that big problem, break it in small, but it's going to take it multiple iterations for you to do it. But each iteration is not resulting into the final product or valuable product like an Agile. Each iteration getting me closer to the phase in which I want it to be operational, right? So you can have within the inceptions or elaboration, you can have multiple phases that allows you to incrementally figure it out the solution. Same thing even in the constructions, right? Once you figured out all those solutions, you can still do the construction into multiple segments, bring it all together before finally deploying into the real production. Okay. If you take this approach in building software, it's called a rational unified process. It's typically used it for, not for a small project, it's used for a little bit bigger projects. Okay. And the third one is a waterfall. Okay. The key difference in Waterfall compared to the first two methodology is you didn't have to have all the details up front. You're learning as you go through it and you're adjusting it. In case of Waterfall, the mindset is, I need to know everything before. I want to know all the requirements, whatever you wanted before I build anything or even design anything.
Right.
Once I know everything, I'm going to go ahead and design it. Okay. Once I design it, I'm going to give it to the implementation guys to build it for me. While I was in the middle of the building and they said, oh, you know what, I want to add this thing. I'm going to go back into the requirement, what all you wanted. Then I'm going to redesign before you can begin.
I mean, if the requirement is changed, we need to go.
But go back, right? Because I don't know whether my design will work now that you change the requirement. Think around, you're building the house. Create the blueprint. Give it to a contractor to build it. Halfway through, you decide, oh, I want to add another room.
So obviously.
What's gonna happen? So you said, wait a minute. I know you would start building, I need to go back and look at that.
Right.
Where are you gonna add it? How big the room is gonna be? Because now I need to change all of my air circulation systems, electrical systems, plumbing systems, depending on what you wanted. That means I need to redesign.
Right. This is time consuming, right?
Well, I have to restart.
Restart,
Think of this,
right.
right? I told you halfway through it, I want something else, I'm restarting it.
Right.
And they will charge you tons of money.
Right, well, the money is that, right? First, whether you can accommodate it or not, that's the key thing,
Feasibility. Yeah.
right? Is it feasible to add it at that point or not, right? So as they change the requirements, you need to go start back, right? So think around water, how the water falls, always from the top to the down,
Yeah. that's
right?
very smart.
If you take it from anywhere else, and you said, I'm gonna change it, you have to put it at the top, flow it back again.
Right.
That's what it is. Anytime you change anything, you will go back to the requirement analysis and start the whole thing again.
So you build a software, right? And when you, like, at the time of testing, you find something missing, right? So if you want to add something, you have to go back to the requirement.
Right.
Again.
So if you're changing it, you find something drastically missing,
Right.
may require you go all the way back. Or if you're saying is, hey, it's missing only this bells and whistles. For example, if you're building the house, right? And you said, you know what, I want you to add one more plug there.
Right.
It's not major overload,
Right.
right? Because it's, okay, we're gonna charge you, it's gonna change a little bit, but it is not changing the design. It's not changing the underlying infrastructure or structure of the house. It's okay, you can do that. But if you like, it's kind of to say, hey, I don't want a basement. You build the whole framework and says, you know what, I want a basement. What's gonna happen? We're gonna destroy the whole frame,
Yeah.
excavate it, create room for the basement, re-pour the foundation. And rebuild it, right?
So which one is fast between Agile and Waterfall to build up?
You tell me.
So the Agile like take like 4 weeks, right? So 4 to 5 weeks. Maybe the Waterfall you can build in a couple of days. Is that right?
You've not been around house construction, right?
Now I'm talking about the software.
Forget software, I'm talking
Okay.
about just in general,
Okay.
right? When you have to start everything and perform it only in certain sequence. That thing is always gonna take a longer than if you're trying to do an adapt. Now, there is a misconception, people say, hey, if I use Agile, I'm gonna build it faster. No, you're not, right? All you're doing it is you're identifying what is your topmost priority and giving that priority quicker.
Oh, yeah.
Your end-to-end solution is still probably gonna take the same time.
Right.
It's not faster. But it allows you to deliver the value that you feel it most important a lot more quicker. And it's 80-20 rule, right? So if you ask a user and says, hey, what all capability you want in the phone? They will list you 50 things. Right? And he says, okay, I'm gonna build all 50 things and then give you a phone. It's gonna take a lot more longer. Versus if you say, okay, great, you want 50 things. tell me just the two applications that you will use it. The first and most important. Let me build those two and just give it to them.
Okay.
Building those two applications is gonna be much more faster than
Faster.
building all 50 together, right?
So Agile is faster to deliver.
Agile is faster in the sense of value delivery
Okay.
from the user, but it's not the end-to-end delivery,
Okay,
right? You don't get everything in 2 weeks,
yeah, exactly.
right? That's the misconception. A lot of people say, oh, it's an Agile, you do it in 2 weeks, I'm done. No, it still takes the same time. It's just that in 2 weeks, you will be able to use something
Use something, yeah, start with something. Yeah.
versus waiting it for 6 months to use something.
Yep.
That's the difference between Agile and
So it's
So
not-
since there is one more than one method, can you just like highlight like the advantage and disadvantage of one of each?
so. Hang on just for a moment. I'll ask some questions and we'll get into that. Right, so hang on to that. You had another question?
I
Okay,
have one question.
Okay.
Yeah, so in both model, requirement can change, right? Or, I mean,
so let me answer your questions along with when I answer the
okay.
questions. Okay,
And I was
good.
gonna say maybe Agile in terms of like, say, building a house. Agile, not here in America, but we're talking about like Africa. If someone needs a place to stay urgently, and you build a house, let's say you want to build a story building. And you don't have the money for the whole story building yet. Maybe you can just do the foundation in one room or do the first floor and let the person move in. And then
And you add another building,
you
right?
can
While
take-
you're still.
Yeah, take on the build the whole thing.
Yeah.
Remember, we do that, right? A lot of things in other countries. So you build the first floor, then after 5 years.
Let's keep it to this country. Let's not even, right? So let's do that, right? So in this country, right? You said, hey, I want a house. Right? Great. You want a house with a basement and a big backyard and a patio and everything. Great. We'll just build your house first. Right? Once it's done, then we can always extend the patio. Right? You can make a patio. Then you can take it a basement and says, I'm gonna finish the basement now. Right? You can incrementally add everything. You can add a sunroof. You can add a deck. Right? You can add a barn shed behind it now, right? You don't have to have everything done all together before you can live in, right? You can have a basic structure and then you can keep adding things to it. That's Agile mindset versus Waterfall is, hey, I want everything first. I want you to ask everything. You want a finished basement, you want a patio, you want a deck, you want like it's a barnyard, how big you want, what you want in that, how, all of those things if you have to provide upfront. They build everything and then give you. It's obviously going to take a lot more longer time than just give you the basic house, right? Same concept with an Agile and a Waterfall. Okay. If you change your mind halfway, hey, you know what? Instead of like it's 6 foot by 6 foot deck, I want 20 foot by 20 foot deck. Right. In the Waterfall, they'll say, oh, wait a minute. I need to pause everything. I need to design it. Says, do I have enough room to do it? And all those things. Do I have enough material? Do I have enough labor to do that? Before I can say, yeah, you can build it. And then well, guess what? It was going to get you next month. Now it's going to take you 2 more months. So your timeline is shifting. Right. And we're going to wait it for 2 more months before you can move in the house. Versus an Agile, you already moved in the house. Now I want to expand my deck from 6 feet by 6 feet to 20 feet by 20 feet. It's okay. We'll just have to take it a little bit longer just to do this work. But you're still living in the house, you're still having the value and everything. Okay. Now coming back to your questions. Which is pros and cons, right? So the way I want you to think around it is think around 90s. Right? When people will go buy a product from a company, what was the mindset? You as a user didn't come up with what product you wanted, right? The companies built a product and marketed to you, and you figured out whether it's suitable for you or not. And then if it's suitable, then you will buy it. Sometimes it's not perfect fit, but you will still buy it because you don't have any other choices. Right? in those days, right, the whole product delivery cycle was more waterfall life cycle. Companies will imagine, they will build it. Once it's ready, then they will give it to the users to do that. Flip it today's world. And I'll give an example since I work for a bank, right? And I worked for telecom before, right? In both cases, it stands true. If you think around in the banking till 2000 or even till like mid 2000, the first decade, banks will come up and say, we'll give you this kind of product. You have a credit card as a product, use credit card to do that. Right? You had no control. Bank will dictate all the terms. This is how you can do it. They will build the product, give it to you. You had no inputs in any of that. Right? Waterfall, bank thought through that. Think now this world. Okay, I have 2 girls going into the college, right? And a whole bunch of kids that I interact with it and all that. Right? Earlier, if you, like it's in my days when I went to the college, right? If the friends who went to a dinner together, right? We'll collect the money from each one, we'll give the cash and give it to them, right? Or the only way we could change the money is write the check or give the cash. Nowadays, my kids go with the friends and everything. As soon as they're done, they just do the Venmo. The money is right there. They don't have to worry about freaking checks or go to the bank to get the cash to have to give it to their friends. Right? What it is now changed because of the internet economy and because of the way that the people are expecting it. Customers are driving the product of how and what they want. What that means is earlier, I had luxury to wait in the room, take 6 months to come up with my own requirements for the products, build it, and give it to the people, right? To build the software. Now, customers are demanding it things. And if you do not provide that in a timely manner, guess what? The kids are not going to stick with the bank who says, oh, I'll give you ability to do an electronic exchange of the money in 2 years. Why don't you stay with me? Here's another company provides you in 3 days. What they're going to do? Bye-bye. You're going to go to there. You're going to do that. What it means is, if I do not adjust quickly to the customer demand, I'll pretty quickly will become an obsolete. Think around Xerox, think around AOL. Do you hear about AOL before? That was the first internet company.
Popular, yeah.
In not just the US, that was the first internet company called America Online. Doesn't exist anymore. Right?
Back in 90s.
Right? Have you heard about Polaroid, Xerox? Have you heard about Blockbuster?
Yes.
Yeah.
That's a long time.
Why did they didn't survive? They didn't adapt to the customer's need quickly. Right? If I'm doing a waterfall and says it's going to take you 6 months for anything that you ask for it, will you survive nowadays? Won't, right? So most of the products now, most of the companies are forced to start thinking in more agile. Therefore, they're shifting it to do more agile delivery. Okay, great. Get the feedback, you do it, decide it, right? Also makes more sense from the business point of view, right? So let's take an example of the tech software that I was talking about. Right? I built the first segment to give it only easy. Customer didn't like it. They didn't pick it up. What my investment was only that small slice. And I can make a decision. It's not working it out or I need to change it. Therefore, I'm not going to do it. Versus if I've done it more in a waterfall world, took me 2 years to build it. Tons of money went in before figuring it out. Customer don't like it. I don't need it anymore. Right? It's a waste of money. People go bankrupt. So much money that you borrowed it that you cannot use it anymore. right? So the demand, the way that the market is evolving in today, it's forcing a lot of product companies to start thinking more in agile way. So what you're going to start seeing it is people are going to be more agile because they have to adapt quickly to the changing needs. Does that mean you cannot use Waterfall or RUP anymore? No, that's not the case. Example that I gave you, right? If I need to put a human to the Mars, I need a longer term plan. I need to break it down in small pieces, right? But my goal is not going to be accomplished till I actually put a human on the Mars, right? So I build a propulsion system, move it somebody to the low Earth gravity. Yeah, it added a value, but still didn't put a human on the Mars, right? So for some of the large projects, it may still make sense to go it in more on that, right? But for most of the work that you will encounter in day-to-day manner, what you're going to find it is most of the companies either already shifted to the agile or are shifting from a waterfall to agile, right?
A lot of companies use hybrid methodology, so mix of agile and waterfall.
Right. Well, part of it is it's getting to agile, even though it may look simple,
Mindset.
it's a very hard to adopt the mindset. Like I'm working, it's been 6 years, I've been trying to transform the JP Morgan Chase Bank. We're not there yet. It takes a significant amount of effort, changing the mindset, not only just, hey, I'm going to do that, right? But also in terms of thinking, in terms of coming to an iterative architecture that enables you to adapt to that. It's not a simple way to do it. That's why you're seeing it, what Harshal was saying. Some companies are still doing a part and pieces in agile way, but the overall big projects are still going into the waterfall, and they're plugging the agile into various components along the way.
Yeah, like nationwide, right? So they do like requirements in a waterfall manner. So they lock down the requirement.
Yeah.
But then the design.
And says now it's
implementation is-
delivery is incremental.
Delivery is that.
So does that answer your question? So again, don't take it everything as this or that only, right? It's an incremental, and you need to think around is what your company is adapting and why they're adapting it. And sometimes they are doing a waterfall because they don't figure it out easy way to do the agile either. That's why they're forcing themselves to do it. Sometimes it's a complexity. So when you think around in a service-oriented architecture in the world that we live into it, right? If you change a small piece, it's so much interconnected that we call it something known as system thinking. Because you can't just pull one lever. You need to think around what is pulling up that lever has an impact on all the other ecosystems and how that changes it, right? So it will take it some time for the companies to adapt in different ways. But as Harshal said, you're going to start seeing it that they are picking and choosing the areas where they can improvise it. And it can become more agile or more nimble, reactive to the need of the customers. Okay. Any question on any of the SDLC cycle? Okay. Now, how does software quality fits into the whole picture? Okay. Traditionally, people think it when we talk about people talk only about testing, right? They think around, hey, build a software, now it needs to be tested. To me, that's too late to put a quality in the product. Okay. You need to think about putting quality all along the way. Okay. It has to be an integral part of the life cycle. So let's take an example. Let's say if I'm building a house, and we talked about the important in the analysis, right? If you put in all those analysis requirements, you don't put it into, okay, how big the house is going to be. In order to cool that big house, how many horsepower, let's say AC and heater, you will need it to push the airflow throughout the house. Okay, if you don't think about it, You build the whole house, you build the whole system, and then it says, okay, this 5 rooms doesn't get cold at all, right? Guess what you need to do? Right? You need to retrofit it now with something else. What is the impact of that retrofitting? It's going to be more cost, more time, more work, potentially not optimal solution, right? Because you put a patch on it afterwards. Versus if you were to have somebody who was an HVAC specialist, an air circulation specialist, and said, can you take a look at it, this analysis, and make sure the design is going to fulfill the requirement that was identified in analysis? They could have easily picked it right there before you build anything, and could have like said, hey, you need to fix this. That's the impact of quality early in the life cycle, right? Same thing goes in the software world, right? If you started building a software and somebody says, hey, I want a millisecond response. And they look at the architecture and says, you know what? You have an architecture which goes in order to give this response across the 7 hops to get you the data to you. And each hop is, let's say, 10 millisecond. You're not going to get a fraction of millisecond response. It's going to cost you 70 milliseconds to get through that 7 hops. They identify that, and then you look through those requirements. And, do I need to adjust the requirement, or do I need to adjust an architecture? But it's much more easier to do that while everything is still on the paper rather than on the pieces, right? That's the value of having quality right from the start. So a lot of times when you go and people will talk about testing. To me, testing is just a small piece. The quality is a bigger piece. Testing is something that, hey, it's built it, and all you're checking it, is it working it or as expected or not? That's testing. Versus, did you build it with the quality in the mind so that it's always going to work? That's software quality assurance. Okay. So as you go through it, right, people will say, hey, I need a tester only after my build stage. It's too late by that time, because the defect is already in the system by then. You miss the opportunity to eliminate the defect as early as possible. Okay, that's the value that software. Okay, so let's take a further step. Okay, now let's talk through it a little bit more understanding of how the software project is built and how you go about initiating, right? So when you talk about the planning phase, how do you start from the planning phase to building something? Okay. So before we go, right? So in the planning phase, it's essentially, I need to build a software, right? But you need to figure out why you need to build a software. Let's talk through a simple example. Because at the end of the day, you build a software not for the fun, you build a software to essentially solve a given business problem, right? So first thing you need to think around is, what is the business problem? How am I going to identify the business problems? Okay. So let's take an example. I'm a small mom and pop bookshop. Okay. I have 3 locations in the city and a 1 warehouse. No software. Forget software. Okay. 3 bookstores and a 1 warehouse in the city. Okay. And all I do is I sell the books and make the money. Okay, that's my business model. Okay. Now, if a customer wants to book, right, they'll come to my store and ask me whether I have that book or not. And I'll look for that book. And if I have a book, I'll tell them. Okay. So let's take a scenario. Okay. That all I have is I keep a pile of books. None of them is organized, just a pile of the books. Okay. And a customer comes to me and says, do you have this book? What do I have to do? I have to go through that entire pile of the book just to figure it out whether I have that book or not. Right? If I find a book early in that, it's great. If not, I still have to go through that entire pile before answering him or her a question whether I have that book or not. But wait, I not only look for that and says, oh, I don't have this book, but we have another store there. You can go and check there. You go there, that store follows the same process.
Right.
The third store follows the same process. Then I go to the warehouse, follow the same process and said, oh, I don't have a book. Let's take an example. If it takes an 8 hour for me to go through my entire file of the book. Just to give a customer a simple answer, no, I don't have a book. Takes me 32 hours, right? 8 hours at each of the 3 stores and 8 hours in the warehouse. 32 hours to answer that question. Right? So I said, what if I make it more easier? What if I just take all of my books and instead of leaving it in a pile, I organize it, let's say by title, alphabetically. Right. Now, if somebody comes and asks me a question whether I have that book or not, probably I'm going to get them answer in a half an hour, worst case scenario. Right. So I've reduced my time from 8 hours to 1 hour. But what importantly I did is I improved the process of looking through the book to answer whether I have that or not. Right. So if I solve it that's called a process improvement. No software, right? I didn't change anything. I didn't do any sophisticated software. I just improved my process to be more effective. That's a process improvement. Because my goal is to make my process better. I don't want to wait for 32 hours. I said, can I do it more effectively? Right. Another view I can think around it is, it was taking 8 hours. Right. Let's say I have 1 employee. Right. I have it. If it takes me 8 hours, all I can do it is serve 1 customer. Right. So what is productivity of my employee? Helping 1 customer at a time. Right. Right. If they goes through 4 employees to give me a simple answer, well, no, I don't have that book. It took me 4 employees, 8 hours, 32 hours, right? To go through it. Right. So productivity is, it took 4 employees to serve 1 customer for a whole day. And I said, you know what? I don't want to take that much. I want that particular employee to be able to serve 4 customers a day. In order to do that, I said, okay, since you want to help 4 customers a day, what is the effective way? Well, what if the employee can get the same answer in 2 hours instead of 8 hours? Whether they have the book or not, right? Right. Well, let's just organize them in alphabetical order. Right. Now what did they do? Hey, I improved the productivity of the employee. Same problem, same way I solve it, right? But my priority 1 was improving my employees versus I want to improve the process. See, same thing, I solve it with the same way, but my primary drivers were different. In one case, I wanted my employee to be more productive. The other case, I wanted to find the book quicker. Okay. The next thing comes to cycle time improvement. Right. So in the first example, I said it's going to take me 32 hours to finish 1 cycle of finding the book. I want to reduce that 32 hours to, let's say, 2 hours. Right. So there are ways I can do it. Right. As soon as customer comes to my store, I can pick up the phone and call all the 3 stores and says, search if you have this book or not. And if you find it, give me a call back. Right. So now all of them went in parallel. And it's organized alphabetically. So now each store can answer in 2 hours whether they have that book or not. Right. But instead of doing sequential, I made it all parallel. Right. So at the end of 2 hours, I will have an answer whether I have that book in any of my stores or not. Right. So cycle time to search the book now got reduced from 32 hours to 2 hours.
Right.
Right. If my goal was to reduce that cycle time, I could do that. Okay. The next motivation could be reduce the cost, right? One of the business problem is if let's say I pay $10 an hour to an employee. Okay, and if everything is in pile, to answer a simple question, whether you have this book or not, cost me 32 times 10, $320.
Right.
Right? So my cost to answer that particular question was $320. If I want to reduce that down to, let's say, $20, right? There are multiple ways I can do it. Can have as can employees do multiple search in parallel, right? So if 3 customer comes and they give me a list, I can look at all 3 lists and says, while I'm going through the pile, if I find each one of them, I'll keep separate. So now I'm doing multitasking. I'm doing 3 things at a time. That's one way to reduce the cost. Or I can organize everything in alphabetically and have them not or take it like that much time, but find it out quickly in 2 hours, go through all of that set and answer that question. Right? The cost is reduced from $320 to $20 because I was able to do that. Right? But here my primary motivation to reduce my cost. Right? And there are multiple ways I can reduce the cost. Right? And I decided that the way I was going to do it by alphabetizing all the books. Right?
Okay, yeah, the client or the customer can even go and look for themselves. That you might not even have.
That could be a cost, right? It's alphabetical order. You just, instead of having an employee look at it, you can just say, hey, the books are there. If you find it, it's great. If you're not able to find it, let me know. Right? That's another way you can do it, right? Now, none of the 4 solutions we talked about has anything to do with the software. Right? Same way you could do it. Okay. Now, let's say I need to improve my market share. Okay. What is my market share if I'm forcing people to come in the door and then look for the book or pick the book on? It's only the people who can come to my store, right? That's my market share. What if I'm like it's in Columbus and I want to have my customers from all 50 states? They're not going to drive it to my store to pick a book. That means I need to provide alternate. What if I just say, okay, you know what? I'm going to give you a phone number, right? You can come to my store or call this number and we can tell you whether we have the book or not. And if you have a book, we can work with you to take your order, take your payment information and ship the book to you. Right? Now, my market share is what? Anybody who can make a phone call to that number. Right. It's not just only those people who can come into that, right? So I increase my market share from the people who can physically come to my store to anybody who can come to my store or who can call to my store.
Yeah. But the problem is how are they gonna know the number of this store?
I can do a whole bunch of marketing advertisement, right? That's a campaign.
Okay, but don't need a software, right?
I don't need a software. I could do it like in a Super Bowl. I can just put an ad, call this number if you want this service, right? I don't need a software. Then they can start calling that number, right? That allowed me to improve the market share, right? So remember, that's a business problem. What is my business problem? Hey, I want to be a better process, or I want my people to be more productive. Right? I want to reduce the overall time it takes it to help a customer. I want to reduce my overall cost to help a customer, or I want to be reach out to more customers. Right? You know, my business problem is going to be in any of those domains. Now, if I may do one thing, may help any other 3 or 4 areas, that's okay. But my primary reason why I want to build certain things is driven off by one segment only. Right? So let's say when you go and say, I want to build a house, right? Your primary reason to build a house might be, hey, I want a better quality of life, right? Or primary reason will be, I'm sinking so much money in the rent, which is going in nowhere. I might as well as put that money towards my own house and build an equity. That might be my primary reason.
Privacy.
As part of the primary reason, I may still get a better quality of life. Right? Or as you talked about, hey, I wanted my freedom in terms of privacy. I don't want to be in a multi-story house. I want to be in my own backyard, private backyard that people are not walking all the time. That might be a primary reason, right? Again, you may have a different thing, or one of the process improvement is, hey, you know what? This house is an hour away from my workplace. Every time I go, it takes me an hour. Well, what if I just get into a public transportation? I can be productive during that hour, still an hour away, but it's a process of improvement. My time is better. Right? So you may still have one primary reasons and you can still get the additional benefits. That is still valuable, right? All you need to think around it is all of your business problem starts with what is your primary driver? What is the key reason why you want to build something? Now, in the book example that I gave you, right? I can just say, hey, you know what? I can write a software which allows me to find the book very quickly. Right? Can look through inventory, index inventory, and then allow people to search on it. Right? But again, why I'm doing that? I could be doing it because I want to build a website that anybody can access from anywhere. They don't have to come to my store. If that is the reason, well, I'm increasing my market share. Right? Or if I would say it's process improvement, hey, it takes me a long time and many people to just create a catalog of the books. What if I keep everything online and people update it quickly? Now it's an instantaneous, anybody can see it from anywhere.
No, so you don't have to take hundreds of like thousands of phone calls.
Right? So depending on what I wanted, right? So cycle time improvement, it could be is, hey, people are like waiting 2 hours on the phone call to get their phone call answered. Versus what if I put it in the web, they can do it themselves. So it doesn't take 2 hours, they can find it within 20 seconds. Right? That's a cycle time improvement. So again, every motivation will be a primary motivation, then there are side benefits of it, you can get it. Or side disadvantage, you can get it, depending on the solution that you pick. Okay. So always in the planning phase, you start with what is your business problem and how you're going to solve it. Is there a valid value to solving that through the software? That's all you're looking for. Okay. So let's do a quick exercise. So now it's time to tell you what's in your folder. May I borrow your folder? Okay. So if you look into the folder, okay, and I'll tell Sneha and Thomas in a moment of how it is organized on the web. Okay. But the way it's organized is in the first tab, till you reach it, is all of your PowerPoint slides that we're going to cover throughout the course. Okay. If you flip it through the first tab, okay, the next tab is essentially some of the exercises description. Okay. Flip the tab.
Okay, so can we write something here?
Yeah, sure. It's your folder. It's your folder. It's your folder. Do whatever you want with that. All I'm just saying is how the folder is organized.
Right.
Okay. So all of the some of the exercise information is in the second tab.
Exercise.
If you flip the third tab, it has some project documents. Okay.
Do you not know for?
No, she has it. I'm just pulling it out and walking her through it. Okay. So it has a whole bunch of project documents, and we'll hold on to that before we call it a day today. I'll tell you what to do it and what you can do it. But those are the project documents. Then if you flip it, the next tab, you have some test plan document. And I'll tell you what to do with that next week. Okay. And then when you flip it, the last one, you have some additional documents, which is, we'll talk as we go through it. Okay. So for you, the most important is the first three tabs. The PowerPoint slide for now, the exercises, and the project documents, right? So we'll go through those three today. For online, what you're gonna see here is Harshal is gonna send you three different documents.
Everybody, I sent to.
So he has already sent in information. It has exact same documents, just how they are organized, is all it talks about, and he has already sent you an email. Okay, so take a look at that email. So. For now, I want you to flip to the first step where the exercises are there. Okay, so go beyond all the PowerPoint slides. Flip it to exercise tab, where it's gonna look like this. Exercise 1, business problem. Is everybody with that? Did you find it? Good. Okay, here is what we're gonna do. Okay. So this is the business problem. Think around this 5 categories. What I want you to do it as an exercise is to read through that exercise 1, which is only a page. Okay. And think around which one of this 5 problem they're trying to solve as a primary problem. What is the motivation that they are describing in that business problem? What they're trying to do it? What business problem they're trying to solve it? Are they trying to get a process improvement? Are they going to try to get the productivity improvement? Are they getting the cost reduction? They're getting market share, or they're getting the cycle time improvement? Okay, so read through that, think through it, and then we'll discuss which one of this 5 problem. So I'm going to give you 5 minutes to read through that exercise 1. Okay. Which is, if you look into, this is pretty much it, right? What you're seeing in the screen. Okay. So it's 11:38. I'm going to give you time till 11:45 to read through it and put your, as an individual person, and put your mind through it. Which one of this problem is the primary problem they're trying to solve it? Okay. Sneha and Thomas, did you guys were able to pull up the document?
Yes, I was able to pull it up.
Yes, me too. Thanks.
All right. So spend time till 11:45. Think around which one of the main problem it's trying to solve it through this description, and then we will talk through it.
Credit card application for the customer. That's why I'm.
Ready?
Yeah.
And need more time? Anybody needs more time? All right. So this is what I'm gonna do. Okay. All right. So we have 9 people in the class. Okay. I have 2 teenage girls, or now they're not teenage anymore, 20 plus now. So I know when people try to deflect all the questions. I have first-hand experience with the girls. They've trained me well, and then I've taught well over the last few years, so I know exactly how this thing goes. So here's what we're gonna do it. There are 9 participants, 7 in the classroom and 2 on the line. Okay, and I think it's, last I checked, my elementary math is still good. So I'm gonna go around the room, and you're gonna tell me which one of the primary things that we talked about that's gonna throw it, okay? So how many of you think the problem that you just read it, primary thing they're trying to address it is a process improvement? If you say it, raise your hand. So 1, 2, 3, 4, 5, 6. Sneha and Thomas, do you think it's a process improvement or anything else?
Yes, it is a process improvement.
Okay, how about you, Thomas?
Yes, it is.
Okay, so all but Joyce, you have raised the hand for process improvement, right? So the way I'm gonna say it is 8 of you think it's a process improvement. Joyce, where do you think it is? What kind of problem it's trying to solve? No, but what is the primary? What is the main reason why they're trying to do it?
Okay, that is the process improvement.
You also think it's process improvement? All right. Do it is. So all of you think it's a process improvement. So humor me and tell me, why do you think it's a process improvement? Why do you think it's a
You
process?
don't have to go from the customer to the dealer to the vendor.
So it's a process improvement from whose point of view?
Business owner.
Business.
Who is the business owner?
Finance.
Amazon.
Arflon. What is the business model?
Business.
What exactly they're trying to solve it? Let's shift it.
So.
So you think it's a process, in the process of fixing the car?
Mhm.
Yeah,
That's an improvement, right? So you're saying is that fixing the car is the process improvement,
loan process, basically.
or a loan process?
It could have, it will also obviously improve cycle time improvement.
Well, I'm not worried about secondary thing. All I'm worried about is what is the primary business driver? Why that? Okay. So when you fix the car, that's a process improvement, right? That's what you, all of you think. Everybody in agreement? Fixing the car is the process they're trying to improve.
You won't fix the car until your loan is approved, your process is.
Okay, so it's not fixing the car, it's the overall of getting back into the right
It's
mode.
the workflow.
It's the workflow improvement, end to end, okay? All right. So who benefits from that?
Dealerships.
Dealer
Dealership?
and the customer, because the
Dealer and customer?
Everybody.
Who, what do you say, Thomas?
I said everybody gets benefited, basically the owner and the end consumer, everybody and the person in between.
Okay. All right. It's great. Dealer benefits, customer benefits.
Yep.
Who is paying for you to build and solve the solution?
vendor.
Lender is paying?
The
Customer
dealers pay
obviously.
for the.
Is dealer is paying it?
for the software.
Where did you read it, Lasha? Walk me through it. Where it says dealer is paying for the system.
Oh, no,
He
the
only
Apple
does-
is providing the service for the.
Arflon is providing the service.
Is offering.
Okay, so if I fix the process or fix the car, how does Arflon benefit? Why did they care? I fix your car in 2 days instead of 5 days?
Because you start fixing the car right after the loan is approved, you don't have to wait.
Think it from our flown point of view. Why, I'm not there to do charity. Right? I'm a for-profit organization. Why do I care your car gets fixed faster? What's in it for me?
Because the faster you fix, you'll have more customers. Word of mouth.
Probably.
More customers. How do you know I'll have more customers?
What
It's productivity.
At that place, it took a week for my car to be fixed, here it got fixed
Okay,
in 2 days.
if it got fixed in 2 days, who benefits? The dealer, right? The word of mouth, they're gonna say, go to that dealer and he'll fix your car faster. Right? The dealer benefited. How does our flown benefit?
More
Maybe the
customers.
finance interest.
More dealership they use the software, more money get in.
Say that again?
The more dealers they would use the software, more money they come into their.
Right. So if I'm a R flown, am I really interested in fixing the car
No.
reduction, process
You want
improvement?
to use the software.
I want more people to use the software. So is it my problem or process improvement? What I'm trying to handle it?
Market.
It's a market share. It's not the process improvement. You have to think it from a business point of view. Who is the business?
I'm thinking about process improvement on the dealer point of view. It's the process.
Yeah, but dealer is not paying it. Dealer is not funding it.
I'm not talking about the software. I'm talking.
I'm not even
talking.
So think about it, right? The dealer is going to take the same amount of time to fix the car. It's essentially when they start fixing the car is changing.
So if you're talking about the workflow of the dealer, like from the start, like the customer getting more car, asking for a loan, like it takes you weeks, the
Right,
next day. But if they use the software.
right, but the dealer is not funding it. If you look at the description, right? Who is funding it? Yeah. Right? Read the first sentence. Our flown is financing it. So I'm always gonna look for my benefit if I'm financing it. Everybody else benefits from the whole process is a secondary thing. Right? I'm not here for others' benefit. I'm here for my benefit.
Because
And as you pointed it out, right? The more the customers uses the software, the more benefit I get it. Why? Because I get per transaction fee. So more the transaction comes through it, the more the benefit for me. Right? So now again, all of you thought about the process flow, right? All you just say is it takes it more to manage the flow. But most important thing is that it's not a single commercial product today. So as AR flow, I'm getting into the market that no competitor exists, and currently the market share is 0. The more the customers I'll get, the more the market shares I will get it. The more the money I will get it. Right? So it's an important to understand who the business is, what is driving their desire to build what they're asking you to build.
The problem is productivity.
The problem category is most important because that's going to drive it. What do you focus on it while building the software?
You're gonna be more productive.
Right? All you wanted is more market share. More the number of people will be able to use the software, the more the transaction will go through it, the more benefit I'll get it. And the way I can do it more is where the people normally go to get fixed car, auto repair shops. So more the number of auto repair shops is on my platform, providing customer, hey, you don't have the money, you can get the loan to fix it. Right? That means the more the application will go through it, the more the money I will get. That's the driver for this software. Okay. Now here's the important thing, right? All of us read the same document. Right? We had a little bit different perspective. What it tells me is it's important to understand the intent. Right, so in this case, the intent is who is benefiting it? Our flow. Right, so one of the most important skill you gain it is understanding the requirement, making sure you can put into the context of which it is looking the business problem, and understanding from that point of view and then building the test cases. Okay, so as you go through it, that is important skills that you need to apply for all of the work that you do. Okay, understanding it from a user's perspective. Making sure if it's not clear in the written document, making sure you have clarifying questions so that you have the right context. Okay. Any questions online? Thomas, now?
No, I'm good.
Yeah. So let's walk through it. I know it is very small in your printout. That. So we talked about the planning phase, but I also want to give you a quick 30-second overview of how it happens in the real world. Okay. In the real world, most of the projects in a firm usually go through what they may have a steering committee. Okay, so whenever you're looking for a proposal, hey, we need to build a solution or build some software, they have a proposal committee which usually goes to, which has a business and a technology representative. When you put a proposal, they ask you, what is the cost? What is the timeline? And what are the benefits? Okay, so any proposal that you put in, they look at from those three angles. Okay, based on that, they determine, is it a useful investment? So let's say if you say it's going to cost me $1 million, it's going to cost me 12 months and gives you a return of $100,000. Is it a good investment? Probably not, right? I invested $1 million, spent 12 months, right? Obviously, I have to take that money from somewhere, right? So the cost of the 12 months, that $1 million, is including the interest, right?
Right.
So it's $1 million investment, but it truly cost me, let's say it was a 10% interest.
Right.
Flat, right? So it cost me $1.1 million at the end of the 12 months. And you're saying you're going to return me only $100,000?
Right.
I'm not going to pass you the product, right? If you say it's $1 million investment, it's going to take me 4 months to implement, and it's going to return $5 million. That's a proposal that I can think around, right? And we can dig it more into that. So they look at through those three lenses as they go through it. Okay, they look at it. What is the cost? What are the benefits? What is the realization time? Okay, once I have that data, it goes to that group. The group reviews it and says, does it make sense? If it does, they said, yep, go ahead. We'll approve your projects. You can start working on it. We'll get you the funding. If it is not clear, they said, you know what? You're talking about this, but you forgot to take this and this in consideration of, you said it's going to generate $1 million revenue, but there's going to be 5 other competitors. So tell me, how are you going to make sure that you're going to be better than the competitors on that? So they ask you to do further analysis. You do that, you go back, get that analysis, and then again, put it through those three lenses and go back through it. Okay. And then they will make a decision. Make sense? Yes? Good. If it doesn't make sense, then they said, no, we're not going to do that. If it doesn't make financial sense, it's a good idea, but it's not beneficial idea. So they will reject it and go through it. That's how the normal process works. Okay. What it means is you need to understand what is the high level cost estimate it's going to be. Right. So if somebody gives you, here is the system, here is the features you want to build it, how long it's going to take it and how much it's going to cost you to build it. You need to think of that too, right? For example, when you go to a builder and says, you build me a house, right? He said, sure, we'll build your house. You ask it, how much it's going to cost? I don't know how long it's gonna take. Maybe 6 months, maybe 12 months. But how confident are you gonna go with that builder to get your house built? Right? Same concept. If you're not sure, they're gonna ask you to go do some more analysis, get some more details, and then come back and do that. Unless you're sure, roughly, it's gonna take 8 to 9 months, it's gonna cost me $100,000 or $200,000. Now I can put my arms around it and say, is it valuable or not? If it's not valuable, I'll go with somebody else. Right? Okay. Once you've finished the planning stage, the next phase is analysis, right? So once you get the funding, or once you decide, I'm gonna build a house, right? It's for your time to figure it out, what all you want in that house, what capabilities, features you want in the house. Same thing with the software. If you decide you're gonna build a software, now let's look through it, what all you're gonna build in the software, right? And that process is done through what is known as requirement analysis. Okay. And then you can think it requirements from two different viewpoints. One is from the customer's viewpoint, which says, I want this capabilities. One could be from an implementer point of view, which tells you what are the system requirements you wanted, right? So business requirement versus system requirement. Those are two different viewpoints. What you're gonna see it is most of the companies, you're gonna have a double end of it. They'll tell you the business requirement, and they will also tell you what are the implementation or detailed requirements. Okay, which is geared towards people who are building the software. Business requirements always geared towards the people who are going to pay for the software. Okay, or use the software. Okay. So when you look at the requirements in the software world, okay, there are two types of requirements. One is called a functional requirement, and other one is called non-functional requirements. So let's say functional requirements. Let's say you're building a website. Okay. And you may have a requirement that says it will ask users to give a criteria for the search. Okay. Based on that criteria, it will return the results that matches that criteria, as long as it matches and holistically, right? So let's say if I'm doing a search and say I want to say it's today's weather. Let's say that's a search criteria. Then I want to return all the results, all the sites, which gives me the information about today's weather. It doesn't give me information only about weather or information about today, but it gives me information collectively what is today's weather is. Right? That's my input. The processing will be anything that matches today's weather criteria I will return. If I do not have any information about that, then it'll give me error processing. Or if I didn't have it, or the weather site from where I'm pulling it is down, it'll give me an error message. Right? If I try to identify that, that's a functional requirement. But if I say it is a non-functional requirement, that hey, I should be able to access this website from anywhere, and it will return the results within 5 seconds. Right? That's called a non-functional requirement. So it's not talking about functionality, but it's talking about the usability and all the other aspects. That hey, if it doesn't return the results in 5 seconds or less, that's not fulfilling or meeting the requirements. Right? So when you say it, like it's, hey, if you're moving in the house and house should have hot and cold water, that's functional requirements. But if it says house should have hot water and it should always be instant hot water, that means as soon as I switch on the hot water tap, it should come hot water. That's a non-functional requirement. And it'll tell you that, hey, it should be 100-degree temperature. That's non-functional. Okay. So functional requirement tends to focus on what the business user wants it. Non-functional requirement talks about the operational characteristics of it. In other words, from where I can access it, what all interfaces it require, what kind of human factor required, like it's when I say website, right? It says, hey, it should have a clear search bar where you can type in things. That's a non-functional requirement. It also talks about the data, it talks about the security. Right? Who all can access it, what all information can be accessed by whom, right? That's all non-functional. It also talks around some of the quality aspects of it. Okay. So how long the system is going to be up? Is it 24/7? Is it only during 8 to 5 the working time? And if it goes down, how much time it has it before it should be brought back up? For example, I worked for 20 years in a telecom firm before. And we built a whole bunch of systems which are critical for people, right? So when you call a 911, right, that has specific system requirement. It needs to be 24/7 up. It needs to have a dual backup. So in other words, if my primary site is down, that doesn't mean my 911 call won't go through it. It will always go through the other route. It'll always do it. The other aspect was in terms of it, if the system goes down, literally you have fractions of seconds to bring it back up because people's life is at stake, right? And there's a hefty fine if your system is not up right away, right? So those kind of quality aspect that tells you is, hey, I can bring it down only for 5 minutes in the whole year for maintenance. That's 911 requirements. You cannot go anything more down than that. Now it's even more stringent with that. It's like always dual backup. So if it goes down one, system is not down the other one, but you can bring it down one node only for 5 minutes because there always needs to be redundant. Okay. And then meantime between the failure, how often it can fail, how often it should be allowed to fail. Okay. And if it fails it, how long it takes it before you can recover. Okay. So that's the mindset in terms of when you talk about non-functional requirements. Okay. So when you look at any of the requirement, whether it's a functional or non-functional, okay. Now, if I wear a quality assurance person hat, you need to think around anything anybody gives you in terms of requirement. Does it meet what we call it as a 3C and a T? Okay. So every requirement you should always look at from the lens of 3C and a T. Okay. So the first lens is it correct? Okay. So when somebody gives you a requirement, you need to look at it. Does it fit into this business problem domain? Is it correct? Right. Let's say if I'm building a bookstore system, right? And if somebody gives a requirement that, hey, it should also tell you what today's weather is it correct? It doesn't even belong into those problems, right? Right. So anything such like that, then people try to put it there insert, you should call it out. It's not correct, right? Perfect example, right? Our government doesn't work this way, right? So if they say it's, hey, there is a bill, all the different senators will put their own sugar items into that, right? You will say it's about students, but those 5 things doesn't even relate to it, but that is input, right? You need to look it into the software when you're building it. Does it requirement really belongs into the problem domain? If it doesn't, you say it's not correct. Okay. And if somebody says it's correct, tell me how it relates into this problem. Have an understanding. Second aspect it does it is it consistent? Okay. So if you have a layout that, hey, system should respond in a reasonable time, let's say, one place, it should be a system should respond within 2 seconds. The third place, it says system should respond back within 5 seconds. Now you have 3 different interpretations. What is the system supposed to do? Is it supposed to get reasonable time? And what is reasonable time? 2 seconds or 5 seconds? Right. So you should look through that and say, wait a minute, it's not consistent. It needs to be consistent so that you can implement it consistently. Okay. The third aspect you should look into the requirement. Is it complete? Okay. So for example, if they say it's refer to the table identified in the appendix, but when you look into appendix, there is no table. Is it a complete requirement? It's not, right? It's missing pieces of it. Or if somebody says, hey, it should go off into all the standards specified onto this site. And if that site doesn't exist, what standard you're implementing it? There is no completeness on what exactly you need to do. Okay, so what you need to look into it is anybody gives you any requirement. A, is it correct? Is it consistent? And is it complete? Because now that gives you the whole picture, what you need to do. The next test that you need to do it is it testable or can I verify this requirement? Right? The example that I gave you earlier, right? The system should respond in a reasonable time. Can you test what is a reasonable time? Because my definition of reasonable time could be completely different than your definition of reasonable time. Right? If I'm generating it a trade execution, right, happens in a millisecond, right? Because the prices fluctuate. When you're looking in the stock market, the prices fluctuate every millisecond up and down. And if it says, oh, I should execute my trade within 5 seconds, is it really good? I don't know. But is it, can I verify that? Did your trade executed in 5 seconds? Yes, I can, right? So it is a testable requirement. Even though it may not be correct or consistent. Right. So you need to make sure everything that they provide as a requirement, it needs to meet both 3C and the T condition for you to be verified. If you cannot manually say it's I cannot verify or it's not complete or not consistent, you should flag right there, because if the system gets implemented, it will not meet the same intention that the user wanted, because A, that intention was not very clear. Okay. So you need to make sure A, correct means everything is actually something the customer needs. Is that something you can test it? And is it consistent across it? Okay. Once you do all of that, then it's a good requirement. Okay. And the way you collect requirements, there are many methods. Okay. Typically, you will not, as a quality assurance person, will be collecting the requirement. They'll be collected by a business analyst, or users will be identifying and describing it what they wanted. Okay. Your job as a quality assurance person is to participate in that process and make sure it meets those 3 conditions. Okay, is it 3C? And then can you verify and test it? Okay, that's what you do. If it is not there, you should ask a question that helps you to get that understanding and that clarification. Okay, and typically the way you do it is through an interview process or questioning it, working with the business users to understand what is the goals and benefits. So when we started doing that exercise, right, I asked it, who it is paying for it and what is their goal, right? And that drives your understanding and subsequent questioning it. Hey, if it was a dealer who is trying to do it, then your mindset is going to be different versus if it is our flow, and your mindset is going to be different. Okay. Again, you're trying to gain the understanding of the problem. And as you go through it, you want to make sure you're not asking the same question over and over again. Right? Because if the customer has already answered you that, you keep asking the same question, they will get irritated. What exactly you're not understanding? Right? So it's your responsibility to understand the context. And typically it gets done through interview and questioning. Okay. Okay. So here's what I want you to do. I think we've a little bit ahead of the schedule today, but it's a good time to pause for today. Okay. Remember I said there is 3 sections that I want you to worry about. We talked about the PowerPoint slides. We talked about the Excel. Now it's time to look into the 3rd section. So if you flip into the 3rd section, okay.
Project documents.
Project documents. Okay. So that section has 2 documents. One is called a user requirements document, and the other one is a design document. So if you go through it, you should see it, this document, which says requirement specification document. Okay, everybody found this page or this document? At the start of section, you should have the. Okay.
Yeah, for online books, I have pasted a link in the chat with the document.
Okay, so you should have the link in the document, Sneha and Thomas. That Herschel pasted it,
In the chat.
okay? Now. This is what you would do, that's a requirements document, that's the project that we're gonna use it for the entire course. Okay, so all of the activity we're gonna do it is around this particular requirements document. Okay. And then if you go, it's about like 27 pages. And then if you go through it. There is also. Another document right behind it, and it's called. A system design document. It's in the same section. It's in the same section. Okay, there are two documents. In the same section, which talks about project document sections. There are two, so if you flip it through about. Okay, did everybody found it? System design document? Okay.
Yes.
Huh? There are two different documents, that's why there is a page number at the bottom. Then just print out the page numbers. Okay. So between now and next Sunday.
Sunday or Thursday? I just sent out email for Thursday.
Okay. So. Thursday is when we're gonna discuss it. Right? So what I want you to do it is read these two documents. Understand the context. What exactly the problem is trying to do it. It's the same business problem that we just started the R-Flown one. Okay? And as you go read through the document, I want you to flag it out, anything that you don't understand, or anything that you feel does not meet 3C and T condition. Out of those two documents.
So we need to read both of these, all of these, right?
You should read all of that document,
First one.
okay?
Till it gets deep.
All 70 pages.
Just don't go by pages, there's
Okay.
a lot of diagrams, lot of images,
Yeah.
you need to understand, important part is. Understand,
The goal is for you to understand what are the requirements,
not memorize, understand.
okay? Anything that doesn't make sense, you should flag it. We'll have that discussion.
Okay.
So any questions you have it, you're gonna flag it, and Herschel and I are gonna answer it, what it means. What is the context and so on.
So
Right?
it's gonna be online, right? From Zoom,
Zoom,
okay.
right?
Same Zoom link.
Same Zoom link. Herschel has sent it out a Zoom link.
Okay.
I'm gonna do that. But the most important part is for you to read it.
Okay.
I'll be the first one that says, when you read the first time, it's gonna go like this. Okay, it won't be clear, guaranteed. Okay. Don't get discouraged. Read it again. Till either you have a question or you understand what it means. Okay. It's not uncommon for students to take 2 or 3 rounds of reading before we do it. Now, one thing I'll tell you, throughout the course, we're gonna refer to this document. And every time you look through this document, you're gonna learn something new. You're gonna get more insight into it. Okay, so if you don't get it first time, don't discourage. Don't get depressed. It's not about that. This also happens in the real life. As you get through the requirement,
Okay.
you're gonna have questions. You're gonna go talk to the business users and say, let's understand it. Go start having a conversation with your team or with your development. There are other things that come to mind. Oh, I didn't thought about that. It's not clear. Let me go ask questions about that. That's very common to happen. Okay, it's the process. Remember, we went through it. All of you thought it was process improvement. Right? The more the discussion you had it, oh, it's not that, it's this, it's that, or this. It's gonna happen. That's the whole part of the quality assurance. It's to understanding it is what the business user wants. And that's the discussion we're gonna have.
So we just need to focus on the requirement, right?
Requirement and design document, both of that. You need to finish reading that entire section. Okay. Read through it, because there are certain things that may not be clear to you in the design, requirements document. That when you read the design document, it'll become a little bit more clear. Okay.
This first and the documentation next or?
That entire 60 pages.
Yeah, but how would you suggest we read it?
Read it. Read the requirement document. Just like, novel, like I was supposed to say, you read every pages. What are your questions? You flag it, right? Annotate it. Says, hey, I don't understand this. Let me read through it. Is it getting clarified somewhere else?
Which section of this and then
No.
that part of that.
Read the whole document.
I send them the prior video link. Okay, in the email, you already have a link.
Okay.
To the prior discussion, so it will help you
Okay.
understand some of the material.
Yeah.
Okay.
And if you still have question, write it down and we'll discuss on the.
Right.
Okay.
So what Herschel has sent it out is, for the prior sections, we had gone through the discussions on Thursdays. So he's actually sent it out those recorded videos when we had that discussion. So that will give you clarity in terms of as you read through it, right? So read through the document, watch that video. Hopefully it'll clarify a lot of things. If not, we'll have that same discussion on Thursday. Is what do you have in your mind that is not clear that we can talk through it. Because it's important to understand the context. It's important to understand the requirements before we get into the certain phases.
And this is exactly how it goes at work, okay? When you start on a new IT project, they'll say, hey, you got a week, go through this document. Try to understand that, and then they say, okay, come back and ask questions, clarify it. Next, second week, you're gonna read the documents again, and then you are up and running afterwards. To do all your QA activities. Okay, so they will give you a week or two to actually digest the material and everything else for the project.
Right.
Okay, this is exactly how it goes.
Now, again, just because we are giving you entire requirements document. Don't think that the process works different in a waterfall or Agile. Okay. In the case of Agile, they will talk about, here is the story, or here's the slides that we're going to focus in the current sprint. The process is still going to be the same. It may be a smaller document or a smaller version than this one. What we are after is making sure we understand process irrespective of what development cycle we use it. Okay. Any questions?
Say, for example, what we put in
Say that again.
Say, for example, I was doing
Documents.
Yeah,
Is it documents or the requirement?
Um,
Okay, look at the documents. Then it-
You mentioned
More
about one of the things another consider is the cost.
Right, but as a quality assurance people,
Mm,
you will go based on requirement. You don't have to wait about the time. That is already taken care of.
Okay.
Let's go and forth. Okay.
So, we discussed about the requirement before, right? It's 3 Cs and all that. So how about the documents? We never discussed before, today. Documents.
That's what you're reading it, that's what we're gonna talk. You're gonna read the document,
Right.
and if it says a requirement, did you understand it? Does it meet your correctness, completeness, and consistency requirement? And can you test it? If I tell you, hey, Joanne, go ahead and test this,
Mhm.
can you test it?
So first read documents and the requirement.
As you read the document, apply your 3 C and T lens to
I
it.
think we're gonna spend a lot of time, what it means for correct, complete, and all those things.
Yeah.
Over next couple of sessions.
Okay.
So that you understand what it means for you, okay?
Thank
But at least try to get a bigger picture.
You
of
take
the-
your view of what you think is 3C and T is, apply it. If it doesn't meet your criteria, let's talk about it. Right? That's the whole purpose, is you going through the process of what it means to take a requirements document, understand the intent. If it's not clear, how you're gonna ask the questions and what questions you need to ask.
Oh, so that's the same Zoom meeting, right?
Yeah, same Zoom meeting, we
I mean, the link.
The link,
Same.
yeah, he sent it out Thursday link, yeah.
Thursdays as well as,
It's weird, like all your email didn't send another file.
oh, is it?
I will try to.
Or she'll stop spamming him.
Yeah, but I'm probably sending BCC, maybe that's focused, so, because I don't want to disclose the emails of the
Yeah.
other people in the class.
It always comes from his email address. You will never see email directly from me. It'll come from the same email address.
Oh, okay.
So as long as you kind of just mark it once it's not spam, it'll automatically come in your inbox. Yeah.
So what kind of video you guys gonna say? Is it like a tutorial, how to?
He'll send you a link. When you play it, you'll see it. It's a recording of the class.
Oh, today's class.
No, there's the one that he sent it, he will send it today's class recording,
Okay.
but there is also a recording of the previous classes
Class.
when we had that session on Thursday evening,
Okay.
so you can see it.
Okay.
Similar things, clarification, Q&A, right, that, and we typically walk through the document. And it explains you certain terminology and so forth,
Okay.
but we already sent you now so that you can review it.
Okay.
Along with while you are going through the document.
Right.
Yeah, as Dilip said, technically here is to understand the material is read the document, watch the video, you can pause it as well, and then read the document again at the same time and understand that particular section.
Okay.
Okay.
So where we can find this reporter right now?
He's already sent an email. Oh, this one, today's session?
Yeah.
Today's session, it usually takes 24 hours for Zoom to
Yeah,
generate the
processing
cloud
it.
recording, because we are recording it in the cloud.
Wow.
Once they finish processing, they'll send in a link, and then Harshal will send you exact link for you to access it.
It's probably this class.
Yep.
All
All right, any other questions online?
No, we're good.
Everybody also have a link
No, I'm
to
good.
the. Yeah, so they.
Okay, I'm gonna
both classes.
stop today's recording, so it'll